The wonders of technology. I'm muted. I'm off camera. There you go. They do the abrupt changeover. Hopefully, you all made it over. It looks like some of you did, which is great. Tell your friends to refresh their browser. It will be pointing to the right location now. Welcome to day one afternoon. So we are now going to move into the second part of day one's content, and we're going to start off with a session featuring my colleagues, Steve, Matt, and Charlotte. This one's entitled The Research Panel.
Hey everyone, welcome to the research panel here at SHIPPED25. I'm here with Matt Alford and Charlotte Fleming to talk through some of the research that we've been doing this year. Hello.
How you going?
Hi everyone, how you going?
So we've done 3 reports this year that we're going to talk through today, plus there may be a sneak preview of something else. So stay to the end to get the little bit of a leak of information of something new. We've looked into GitOps, platform engineering, and compliance, and we're going to talk through those today. But first of all, I thought it would be useful if we introduced ourselves. So I'm Steve. I started the research effort here and have worked at Octopus for a little while. I'm in the continuous delivery space, and I also work with the DORA team at Google on the research that they do, one of their community guides. And I'm just super curious about software delivery, and I have been for a long, long time. So that's kind of what I bring. Matt, do you want to introduce yourself?
Yeah, thanks, Steve. So my name is Matt, and I'm a developer advocate here at Octopus Deploy. I've been here for a lot less time than Steve has, and I have the benefit of relying on the brains trust that you see here, being Steve and Charlotte, who undertake all of the amazing research that you're about to see in this session. And then I get to help create some content around that. And sometimes that's in the report itself, but also exploring the findings in separate mediums like articles and videos to share with the world, which is really exciting. And I've spent most of my practitioner life in the operations side of the world, but for the last 5 or so years before joining Octopus, I worked really closely with developers to help them ship their applications, which has kind of allowed me to get really interested and curious about software delivery. So that's really cool. And how about yourself, Charlotte?
So I am a research assistant at Octopus, and I've been here actually even less time than Matt. But I have, as Matt said, I do the research with Steve. So I contributed to the platform engineering pulse report, which we're about to talk about, and I have been working on a few other things. So I do all the surveys and then the data analysis with Steve, and then we kind of work through and make a report, which is really cool. Yeah.
Awesome. And I think one of the reasons this is like a really cool trio of people is because we bring very different perspectives from practitioner perspectives, development and operations, like that perfect DevOps thing, with also that research skill that we're now bringing into it to kind of up our game to do the research far better than what we started with. So it's really useful. I think that crushing together of good research skills with real life experience is where we're going to find out most discoveries. So with that in mind, let's talk about the Platform Engineering Pulse Report. This was a smaller survey that we did in order to start finding out where we should be investigating platform engineering. So we needed to go out and find out a little bit to know what questions we then needed to ask. We're going to be doing a larger platform engineering report, which will be coming out next year. And we also worked with some of our friends from the CNCF on this, such as Saim Safdar, to do interviews with people to find out a bit more about platform engineering as well. And we brought that together with some surveys. And we're going to look through only like a handful of things that we found in this report. With all of these, if you're interested in what we share, there's loads more to find. So definitely download them from octopus.com/publications. These are all free to download. And let's get cracking into the platform engineering space with this first graph. So this one is, it was interesting to me because in the community, we were talking a lot about why you would adopt platform engineering. And the really common things that came up, and I don't know if this is the same experience that you've had, is let's reduce cognitive load for developers. Let's improve that developer experience. Like, there was a lot of stuff that sounded a lot like, let's make developers happy. But those things don't seem to have made it onto this list.
Yeah, exactly. So this is, I guess it was one of the first things that comes up in the report, and straight away there's kind of, I guess, an interesting finding, which was contradictory from what I guess the literature currently or previously stated. So you can see that improving efficiency and standardizing processes were the two top reasons. And if you go down the list, it doesn't mention anything about, I guess, cognitive load or burnout. Which is really interesting. And I mean, I think if I remember correctly, there was rarely anything mentioned like that in the top. Sorry, what was it? There was rarely any sort of developer mention in terms of the reasons why companies were implementing platforms, which is really interesting. Yeah.
Yeah, it seemed to be like a nice side effect to get, but it's definitely not the reason that people are spending their hard dollars on it. So efficiency and standardization and productivity are all words that maybe are a little bit more associated with scientific management rather than maybe modern transformational leadership styles. But equally, I think we can understand that those are the things that must be driving the pain for organizations. So having too many different ways of doing things, having almost like too much sprawl in their estate, and they have to solve that problem. So that's what makes it worth spending money on. They don't want to make developers' lives worse. They'd like to make them better as part of this, but there's more painful things at the top of their mind.
Yeah, exactly. And it's likely that, I guess, I mean, we don't know that for sure, but it's likely that reducing burnout and cognitive load is an indirect effect from implementing platforms like this. Yeah.
Yeah, I was at a user group in London a couple of weeks back, and I shared this chart with them and said I was really surprised because I was expecting to see those cognitive load and developer experience items up on this list. And they basically stared back at me and they were not surprised because they're in the trenches doing it. And they know that the platforms that they're using or building are being driven by other things. So I was more surprised, I think, than practitioners. So if you are either a platform engineer or a developer using a platform, this might not be as surprising to you either, but that's okay.
Yeah, exactly.
Yeah, I was not surprised to see, obviously, standardized process up towards the top there, but it was interesting to see these reasons for adoption. And Steve, I want to pick your brain actually just for a moment. The third one down, increased developer productivity. I know you're somewhat passionate about the word productivity because what does that even mean? And it's interesting to see that here. And I guess from my perspective, it's a general. I would see that as a general theme of having a platform, like the developers should be more productive for whatever that means in your organization. But that one I was really surprised to sort of see it in the top three.
Yeah, productivity is a bit of a trigger word for me because on the one hand, if I made something and I didn't know what it did, but I wanted to sell it to people, I would probably use the word productivity, right? Mm-hmm. Because you can promise people it will 10x productivity, and because no one has really sat down and worked out what does productivity mean, what's the point of it, what value is it going to bring, it means that they can never really disprove your 10x claims. So that's one of the most common places I see the word productivity is when people are trying to sell you something and they don't really have a better reason to sell it to you. And the other part of me that kind of twitches around productivity is we've seen time and again that optimizing one small part of an end-to-end value stream makes no difference unless you've chosen the right part to optimize. So whenever you're throwing productivity around, very often, especially when it comes to things like platform engineering or other tools in this space, productivity ends up boiling down to how do we make programmers type faster, which is not the route to value for any organization building software. So I try to encourage organizations to actually sit down and keep working on that phrase of productivity until they have a clearer picture of what that means. And it shouldn't be lines of code or number of pull requests or even number of features, because they aren't necessarily numbers that will result in better sales or higher value sales or increased attainment of whatever the organization's goal is, whether that's making money or saving bees. Those are the things that we want it to relate back to. And if your productivity doesn't increase those things, it's not a useful concept.
Yeah.
So,
yep. And it kind of reminds me a little bit about the entire work stream and looking at it all kind of like you just alluded to. And if you've got a part of your work stream, like if your pull requests are taking 3 days on average to get reviewed by the team, but you enable them with tooling that helps them code faster at the start, where's the, is there actually a productivity gain there? Because you've probably enhanced an area of the workflow that didn't need it, or improved an area of the workflow that didn't need it, and you've still got that same original bottleneck that you had.
Exactly. And the original bottleneck still exists, but you've now made it worse by pushing more things towards it. Which actually makes it quite a toxic problem. If the code review is your constraint, you don't want to add more things to the queue for code review. Yeah,
exactly. Yeah, I've just done, in my, I guess, a teaser, which we'll tease today, the next report that I'm doing is based on AI integration, and code reviews a huge constraint. And the integration of AI speeds up some things, but not other things, including code review, unless you have found a way to work on that process really effectively with AI. But otherwise, platform engineering is also being used to, meant to increase developer productivity. And it makes sense. It does make sense, really, when you think of those things together, but is it actually doing it? And how is it actually making the developer more productive? That's, interesting.
So the next chart that I'd like to get into, this is actually one of my favorite charts, because the more I stare at it, the more interesting things get. So let's pull up this radar chart of mandatory versus optional platforms. So half of the chart shows where the platform was mandated. Half of it shows where it was a free choice by the developers. And then if you look at it from the other diagonal, it shows the producer rating of the platform, whether it meets its goals, versus the people using the platform. And it tells quite an interesting picture. Charlotte, do you want to explain to us how to read this chart so that we can all stare at it in wonder?
Yes. So I created this chart on Python, and it was very exciting when it finally came together, with Steve's help, obviously. So we've got the producer mandatory over on the left, and we can see that obviously that's the largest portion. That represents 88% of I guess, respondents, in which producers working on the mandatory platforms rate that they are meeting the goals. And then when we go further down the bottom, where producers is optional, we can see that producers working on optional platforms are actually split down the middle. So that's 50% is telling us that they're meeting many or all of their goals. So there is a bit of there's a bit of a split in perception here, in that producers really think that they are producing a great product, and when it's mandatory, it's working, except when it's optional, less people, I guess, are using it, right? And so there's a bit of a, divide here between consumer perception and producer perception, which is interesting.
Yeah, because the interesting comparisons, whenever you go to a diagonal, you can kind of compare something. So when you look at producers' view of mandatory platforms versus consumers' views of mandatory platforms, there's a huge divide. And one of the things that this has popped up a few times recently in conversations I've been having this feels a little bit like the old pre-DevOps problem rearing its head, because the producers on a mandatory platform are achieving all of their goals, but maybe they're not achieving the goals of the developers. Maybe they haven't even asked what the goals of the developers are. So this is definitely a problem that needs to be overcome within platform engineering. Is like, we need to kind of quickly rewind and revise some of that DevOps, reduce the silos, increase the collaboration, and maybe make sure that the goals are shared between those two different teams.
Yeah, I've been having some conversations with platform engineers as part of a series that we've kicked off for Inside Platform Engineering. And the very first conversation I had with Luke Phillips was heavily around non-technical things and, platform engineers or the platform team talking with and collaborating with the users of the platform being such a crucial role of platform engineering teams. And that has come up in every conversation I've had. I think I'm up to episode 3 or 4 at the moment, and it's reared its head every time, because it's such a, we look back on IT from 20 or 30 years ago, and we could kind of be the folks that were sitting behind the keyboard, and we didn't have to talk to the business or the people or even other people in IT. We could just sit there and do our tasks and everything was okay. But some of this information really shines a light on the importance of understanding your users. It's like being at a product company, right? You need to really understand the needs of your users and what's working well and what's not working so well, and where can you focus your energy to make it all about the customer, or in this case, the consumer of the platform.
Yeah, exactly. Yeah.
Yeah, so let's try and have more conversations across that divide. And what I'd love to see would be these numbers coming closer together, because the platform team is now trying to achieve both sets of goals with the platform. Or if it's not goal related, because they now understand that the developers are experiencing some pain with their platform, and then they go and solve it, and then the developers increase their rating that they're meeting the goals of the platform. So I'd love to see this become more of a circle.
Yeah, that'd be really good.
So let's dive in to our next insight. And again, this is another one that I enjoyed it. It brought me some genuine joy and delight. I'll quickly describe what we're seeing here. This is a comparison of, again, we're looking at whether platforms are meeting their goals. And we're looking at that in terms of how many metrics the team is tracking around their platform. And there's a very strong pattern from one metric up of this increase. So if you measure more different things around what your platform's trying to achieve, your platform is more likely to be successful. But there's something interesting going on the left-hand side of this chart. Could someone explain to me what that is all about?
Sure. So this essentially, the 0 is 71% of respondents have 0 metrics in which they track their performance or success, is obviously questionable, because if you are not tracking any metrics, how are you making sure that you're achieving your goals and, I guess, performing at all? I think Steve coined it zero metric success illusion, and it is very accurate. So where platforms are reporting their high success rates simply because they're actually not tracking any data. So it is a bit of an illusion, because how are they aware? How do they have any knowledge of whether or not they're meeting their goals? And, do they have any goals? Have these, have they been, I guess, has it all been planned out, and has it been strategized, and do they have goals to meet? And if they don't, then obviously it's going to appear successful, and that's what this is showing.
I think it's interesting because there's probably a certain number of organizations who need to do platform engineering because everyone else is. So for them, being able to answer yes to the question, do you have a internal developer platform, probably is success, because they just wanted to imitate what successful organizations are doing. But that likely will become a bit of an anchor on their teams if they don't start translating it into real benefits that a platform should have.
Yeah. And Matt, were you going to say something?
Yeah, I was. Well, I was, but it was kind of a joke because I used this zero success. The zero metric success illusion in my personal life when, I think I've had a great week of like eating healthy and that sort of thing, but I don't actually track it. I'm like, oh, I've had 2 salads this week. I must be healthy. But then if I was to reflect on that, I'm probably not. And Steve's actually seen my expense reports from when I travel, and he's probably seen the rubbish that I'm eating and thinking, what are you doing, Matt? So, and what's really interesting, or when I look at this data here about the more metrics, the more success. The other thing I'd say about the metrics that are being tracked, and folks out there, you may be doing this already, but if not, I think it's really important to understand from the people in your business who are funding the platform engineering initiative is to really understand what they are funding it for. What are the goals that they are trying to achieve from the platform? And then make sure that you in the platform team are trying to measure things that correlate directly back to that. So if one of their crucial metrics is to improve the security of code being delivered by the organization when they ship an application, then make sure that that's one of the things that you're measuring in your platform. Because if you're off measuring something else, while that may be helpful in other scenarios, when the folks who are funding the platform and investing in the team and driving it through the organization get asked, oh, are we meeting the goals that we set out to? They're a bit like, we can't really correlate that. So if you're struggling for metrics to measure that you think will have an impact, that's where I would advise starting.
Yeah.
And I think there's an interesting relationship that we're going to see becoming quite important here is understanding why you're investing in a platform, and then measuring that is going to be how you keep the platform when attention starts to move elsewhere. There is always something else coming along that's going to want to displace that funding. And one of the things I don't want to see is all these developer teams who are now using a platform and it's solving a load of problems, be left abandoned. They'll be stuck on a platform that's not getting maintained because investment's been moved away. So platform teams need to kind of move, especially from that zero area, somewhere up this graph into tracking some metrics and showing benefits, so that when people kind of start questioning it, why do we bother with platform engineering? They can say, here are the reasons, and secure that funding, for the longer term. Because you can't really leave developers on a platform that's not got that long-term funding. That's going to be a disaster. That's worse than never having a platform, because they will effectively start hiring people that don't know some of the things that the platform does because they don't need that knowledge. If the platform disappears, there'll be a lot of skill acquisition required.
Yeah, absolutely. And in terms of the metrics you are tracking, I'm now remembering when we did a bit of a deep dive into what people were tracking. It was DORA metrics, which was great, but a lot of organizations actually lacked that developer focused, I guess, any sort of metrics relating to developer feedback, and that is a recommendation that we made in the report. So you just have to have a broad, holistic sort of way to gather feedback and metrics to, I guess, which related to higher performing groups and teams. Yeah,
we recommend 4 metric categories, and that feedback from developers is an entire category on its own. It's so important. We'll throw some more information about Monk metrics at you if you need to know how to measure. But you need to go beyond single point. You need to kind of look broadly at different criteria.
Yeah.
So let's have a look at our final chart in the platform engineering space, which is this one, which is about how long it takes for your platform to be successful. Charlotte, you drew this chart. This was another one of your Python creations. So do you want to quickly explain to us what this shows us?
Yeah, so we've got our little graph here, and it's based on the organizations meeting many or all of their goals by the years of experience, which is on the years of experience is on the x-axis. So this kind of resonates with a previous report which Puppet and Dora have produced, which essentially says that after 3 years in which your platform becomes mature, you're going to experience more success. And success is you're going to be meeting more goals. And essentially, it will keep going, keep going. The idea is that initially you may, meet a few quick, easy goals, and then it might plateau, in which we recommend to persevere, because you really do see those kind of extreme success rates after year 3, which is really awesome. Yeah.
I think that's one of the crucial points, is knowing that it might take 3 years to get to that highly successful zone shouldn't mean that you kind of go to the stakeholders and say, come back in 3 years, right? We'll show you what we've done, because that won't lead you to success. You have to work out how you're going to get the first small win and then the next one. And it's the sum of all of those that turns it into success, rather than it being, it's not 3 years of work and then success. It's like 2 weeks of work and a small win, another 2 weeks of work and a small win, repeated over and over, because you want those feedback loops so that you know whether that new thing you've added is having an impact or not.
Yeah, exactly. And having that, I guess, longitudinal data, you can see by basic decisions and how much they affect success in meeting goals, and you can see it in quite a clear pattern. And so it's really interesting when looking at the data that, it kind of just goes initially up and then down, and then it really does rise up. And that's where, that's the goal is, 3+ years. Yeah.
Yeah. And we see that a lot in software development, this J curve. We saw it with TDD. There's an initial cost as everyone's trying to work out how to write tests and design their code to be testable. And then over the longer term, like, you end up kind of traveling up that hockey stick and getting huge benefits. So it's one of those things, sometimes when you measure something over a very short term, it just tells you to stop all attempts to make things better, because it always takes time to practice and get good at a skill. And I often forget that whenever I'm talking about like testing techniques. I forget how long it took me to go from writing my first test to actually being good at it and it being a way of writing better software. It did not take me weeks. It took me much longer, I'm embarrassed to say. But don't be embarrassed. It's fine. Learning takes time. Okay, so to sum up the Platform Engineering Pulse report, the adoption reasons aren't as DevX as we thought they would be. There's a big divide between how producers and consumers view the success of their platforms. And one of the ways that we might be able to bridge that divide is by measuring the right things. And that should be a combination of the goals you've been given as a platform team and the goals developers have, because the platform has to solve both of those. Let's now move on to our State of GitOps report. This was a large study. We got 660 responses to our survey. And we also did interviews with expert practitioners to help us go beyond our own kind of silo of knowledge. We wanted to get different perspectives on it. And we found out so much interesting stuff in this report. And again, there was a lot of interesting crossover. Code reviews comes up a lot. We've mentioned it already on the call today. It definitely relates to AI. It's come up in the as part of continuous delivery, the importance of having fast code reviews. And that's definitely something which applies to GitOps as well. But let's first take a look at the model we built around the research. So there's lots of boxes on here, but what we have mapped out, and we have lots of diagrams to explore on this, but what we mapped out was there are a whole bunch of GitOps practices which are based on the Open GitOps principles. There's a website dedicated to the 4 principles of GitOps. That's what we use to inspire what we were looking into. And they bring you a whole bunch of GitOps specific benefits, which is what's in this purple box. But they also happen to increase your DevOps outcomes as well. So your software delivery performance and the well-being of teams and the reliability of your services. So there's this really positive effect of these GitOps principles and applying them through the right practices that we found through this research.
Yeah, it was interesting for me to be able to correlate this backwards, leaning on the Dora's research here between organizational performance and DevOps outcomes. And as you work your way through the report, you kind of see that these high performers of GitOps practices and the impact that it has on those things that are categorized there in the DevOps outcomes, which in turn, of course, leads to higher organizational performance. So yeah, for me, it was really cool to see that sort of correlate all the way through.
Yeah, and I think a lot of people missed that in the Dora research. So I think they did it on 2 separate years. They actually went out and tested the relationship between things like software delivery performance and these organizational outcomes. And when we talk about those organizational goals, we're talking about things like market cap and the share of market in their space. So these are like real world useful things that the organization really needs. Not just like, oh yeah, the organization is cool. They're actually winning the market. So super important.
Yeah, and I think that, and this is in the report that you wrote on this, Steve, but it was that you can't, I guess, half do GitOps. The benefits are there when you adopt as many practices as possible. And so, yeah, the correlation, as you both have said, which is there, which is awesome. But the distinction of the declarative state and how much that actually affects high performing teams and low performing teams, I found really interesting. I just found that really interesting. And also because I'm new to technology, like to the tech industry as well. So just coming in and actually finding that declarative state was like had a significant impact on performance, and also a significant impact on whether or not you adopted other practices. I just found that really interesting. That was really good. Yeah.
Yeah, and the idea behind declarative state is that you don't have like a step-by-step, build foundations, add columns, put on roof. You don't do that step-by-step. You just describe the building, and then it allows this whole new class of tools that know how to get you to that state. So you don't have to define it. And that's more robust because you're saying it should look like this at the end of the process, which makes it quite testable. Whereas if it runs through a step-by-step sequential process to build the thing, you would then need some different validation mechanism. So declarative state is a great way of saying this is the thing we want. I think that's what makes it different to the more imperative styles of defining things like infrastructure and what applications you would like running. And interestingly, we know that like the DevOps model, which is really huge and has loads of capabilities in it, those capabilities are just options for you to add. And you're right, Charlotte, on this one, this is really, I suppose, GitOps would be that capability. But within that, these items aren't really negotiable. And we found a lot of people weren't using continuous reconciliation and automatic pull. And effectively, they were also then saying, but we don't seem to be getting the benefits of GitOps. And so there seems to be a real limiting factor of not doing all of the things on this list. So it's worth checking to seeing if you've got something missing and adding it in if it is missing from your GitOps implementation.
Yeah, I think it was, as I'm trying to remember, I think it was something like 16% or 18% or something were the survivors of the funnel that had the highest performing teams. And it was because they had adopted most of all of the GitOps practices. And it was kind of a stark, there was a very obvious, difference.
Yeah, it's really like in terms of how many organizations are doing all of this, like they're not missing anything. It's a really low number. I think it's about 16%. So It suggests that most people doing GitOps have definitely got room to check back and add the missing pieces to their list.
Yeah.
Which segues quite nicely into looking at those relationships. So everyone brace yourself for lots of purple lines. The reason this diagram looks quite cobwebby is because we didn't want to just say, do GitOps, get benefits. We wanted to work out which specific practices resulted in which specific outcomes. So we have things on here like increased security and drift prevention and auditability, lots of really cool things, which is like, these are the reasons GitOps exists, to give us these things. And what we found was there are certain practices that impact many of those outcomes. So things like version control, obviously. If you're not in version control, it's definitely not GitOps. So it impacts a lot of the outcomes, but so does automatic pull, which is something a lot of people aren't doing. So if you're doing GitOps and you're surprised that you're not getting those things on the right, this diagram helps you to kind of explain why you're not getting them. And some items don't impact as many things, like human readable formats. That benefits there are mostly for auditability and for reducing access. That's where it kind of had an impact. But that's still super valuable. So even though there's only 2 lines, don't underestimate how important they are.
Yeah, and there's a really cool interactive diagram on our site, which you can pick and choose, and you can see, if you pick one, it'll show you more clearly, I guess, the connection here. Responsive code review and version control and automatic pull, they're the 3 practices which lead to all of them. Yeah.
Yeah, so they're making a big difference. And the way to use this is to start from the outcome that you want to achieve, and then just follow the lines backwards to the practice that will help you achieve that outcome. And in many cases, it's not a single thing. That's very common in DevOps. Is we'd all love there to be one thing we could do and it solves all problems, but it's more complicated than that. And we have a similar diagram for the DevOps benefits. And we looked at the DevOps benefits because we wanted to be able to connect GitOps back to something that everyone is familiar with by now. I think software delivery performance, those 4 key DORA metrics, there's 5 now if you're keeping up to date with the research. That's kind of an important thing, is to be able to connect it back to other work that's being done out there. The DORA research in particular, we're big fans of, and we love seeing what comes out of that incredibly well-honed research effort. It's been going for over a decade, and they've definitely inspired a lot of what we've done. So we wanted to connect it back. It's important to connect as well GitOps to that bigger picture. Software delivery performance is like a next layer out, and then going out again to those the benefits to the business. That's how we want to kind of think about everything we're doing, is like widening out the criteria for what we think is success rather than ticking off a checklist. I will now get off this soapbox. Shall we move on to, this is the relationship that we found. So along the bottom of the scale, we normalized everything to a score to make it more comparable. And along the bottom, we've got the GitOps score. So the more of those individual boxes that you have implemented, the higher your score is. And we did the same thing with the software delivery metrics. We assigned that so that the more of those you're achieving, the higher your score is. And we found there to be quite a strong relationship. So the higher you score on GitOps, the higher you score on software delivery performance. We have similar charts as well for well-being and for reliability. But this was probably the most pronounced chart in terms of having a narrow error bar and a very steep incline.
Yeah, this is sort of one of the big findings from the report, right? And I think before I saw this, I knew that it was going to be an upward trajectory, but I didn't expect it to be a differential of what have we got, 40 there almost on the left hand side from the lower GitOps scores to the higher ones. So and for me, this comes back to what Charlotte said earlier around those the GitOps principles, especially the automatic pull and the continuous reconciliation, just really strengthening that GitOps score. And then of course here the impact then that has the flow. It's like a flow-on effect. So yeah, super important.
Yeah. So if you're hesitating on those automatic pull and continuous reconciliation items, this should be the inspiration to go back and finish the job. That's probably how we would summarize the GitOps one. Go back and just fill in those gaps, and you should then start seeing this kind of benefit, which is absolutely awesome. So there really isn't a half of a GitOps. You have to do the whole thing. It lands more in that maturity model zone than a capability model zone. It's got its own set of benefits as well as benefits to things that we already are probably measuring. But it does have that huge impact on DevOps, which is super exciting. And speaking of super exciting, compliance. Everyone's excited by compliance, right?
Yes.
Absolutely.
Correct answer. As a bit of background, I used to work in compliance a long time ago, in a different century, in fact. So I have a little bit of experience with compliance, but I've also been keeping up to date on new regulations as they come in. So, once I moved into software, there's always been standards to adhere to, like PCI compliance and SOC 2 and SOC 3 and ISO 27001. And now we had this new regulation called DORA, which is slightly confusing for us because DORA for us is the research team at Google, but this is the Digital Operational Resilience Act in the European Union. But it gave us an opportunity to do a deep dive into what impact that regulation was having on teams, so that we could extrapolate in some ways to say each time a new piece of legislation comes in that means you have to adapt how you're working and how you're delivering software, what's the cost of that? So that's why we were inspired to do the report, because at the time we were surveying this, everyone was implementing, or if they were super proactive, had implemented those changes to meet the DORA regulations. And a couple of organizations said, oh, we haven't actually heard of this, and we're going away now to find out what we need to do. So we also helped a few people to hopefully meet their regulatory obligations. And as part of what we looked at how people approve changes to the software. And this is the first one. Charlotte, do you want to take us through this question of manual approvals?
So we essentially, when we collected the survey respondents, we asked them how many manual approvals are in their, approval chain. And we then were able to score the responses based on high performance and meeting their goals and meeting DORA metrics and all of those things. So you can see this graph here. We've got the score on the y-axis and the manual approvals, the actual number on the x. And you can see that there is a downward trend. So the score, your general software delivery performance score is reduced if your manual approvals increases, if the number increases. So I actually was talking with Matt earlier today about this, but yeah, it's very obvious that there is a very distinct downward trend when you increase the number of approval steps in the approval chain, that your score decreases, and it's because of all these other bottlenecks that appear, right? And we'll go into them soon, but that's what this graph is stating.
So it's a bit of a throughput killer in terms of, if you need 6 approvals. I'm amazed that people need 6 approvals. That does sound like a lot to me. But yeah, that it's too much, and it's probably harming your throughput to such an extent that the economics of that approval is probably wrong. There's always this thing with risk where you have to kind of look at the economics. There is a cost to do something which is beyond any benefit you can ever achieve from doing it. And I'd say 6 approvals is probably in that zone. So yes, obviously, if you have more than one approval, that does form a chain. And we looked at different kinds of approval chain, which is what we have here. If you can't read them all, don't worry. The idea is that we looked at, I've just made a change. Who do I need to get to sign off on that change to get it out the door? And you'll have things like my direct manager maybe is approving it, or maybe another department. Maybe if security is a separate area and they have to approve it, it might go out there. And then there's also a concept of these cross-departmental committees who meet up to approve changes as like a whole group, sometimes in a big room with people explaining their changes to them and then trying to get them to say, yes, you can go live with it. What did we find here?
So we essentially, one of key finding, which is really interesting, is that actually adding your direct manager into the approval chain was an accelerator to the approval process, which was really interesting and I think it probably challenged my assumption of approval process. But I found this really interesting. But when I thought about it on an organizational level, and through Steve's report, it makes sense because managers hold a certain level of authority in which if it does need to go above them for a tick, it will likely just go through because the managers have previously, approved the process, said it was okay, said it was feasible, all of those things. So that was really interesting. Another thing is that including the team that is obviously asking, is obviously asking for the approval, also was likely to increase your performance score. And this also does make sense because the team knows about, they're requesting the approval. They know exactly what they're approving. They know why they're approving it, and they know how it's going to affect things and what it actually will do for them. So having them on the team was also a really, beneficial point as well.
This is an interesting social aspect to this, right? Because when the team is signing off on their own work, maybe that's a reminder to them to do some checks that maybe they might not have done if they were just firing the approval out into the ether. And then the direct manager is obviously well networked and well connected. So maybe it's easier for them to get that external team approval than it would be, if you're a developer just getting ghosted by an external team who maybe are under pressure from multiple development teams, and yours hasn't kind of hit that priority to get approved, but then it's just blocking your work. So there's a lot of social dynamics involved in this approval process, which is interesting. Surely a cross-departmental committee then does this all in one hit, right? Because we get all those people in a room, so it must be faster.
Looking at the graph, if you can see it, cross-departmental committee every time slows down approval process dramatically, in that even if direct managers and teams are on it, they have the lowest performing, they're the lowest performing teams. And it's likely due to the fact that there are just normal scheduling errors for committees. And so perhaps if, there's a slight delay, you'll have to wait till the next review cycle, which delays everything. They're just normal delays, but they would slow down. They clearly do have an effect on performance scores because of the fact that they slow down the process. Yeah.
That makes sense. And from the conversations I've had with people after we published this, some people are trying to solve this by convening their change committee multiple times a week. But we don't really see any change committees working. What we really probably need to do is get back to some agile basics, making sure that our teams are cross-functional enough that we can cover the requirements that are needed. We also want to make sure that we're automating approvals when we can. If we're taking a software version and then we're running a scanner against it, and then approving that and saying, yes, I've run the scanner and I didn't get any errors, maybe that should be part of our deployment pipeline instead of a separate manual check. So I think there's a combination of things we can do. We can automate a bunch of checks. We can put the right people on a team so that they can sign their own work. And then when we do have a separate approval, like handling that in the right way, using this kind of approval chain list, using that number of manual approvals graph, that's probably the way to look at it. So yes, that's how we kind of want to go. And we kind of have a bit more information on this because we have this diagram, and this is a combination of your approval chains, how many people have to approve it, and the number of people who can deploy. So having more people who can deploy, we want this number to be bigger. We found 4 or more people is a good number for who can trigger a deployment, combined with very low numbers of approvals, such as 1 approval. That's where your highest throughput comes from. And you can see that compared to every other way of doing things, this is by far the winner in terms of throughput. So if you want to do something which improves developer productivity, increase the number of people who can deploy and reduce the number of approvals. The jury has returned its verdict on this one, I think.
Yeah.
Yep.
So I think there's a number, and it's like if you have a single approval, it's 3 times. It has 3 times higher performance than the 6 that we saw before, which does make sense. We saw the chart, but also if you have 4 or more people, I think you have something like it's something like a 20% higher score in performance compared to a single, single deployers, one person deploying the software. And so it's really important to increase it seems like quite a simple addition or a simple change. I'm sure it's much more complicated, but I mean, just increasing the number seems like a logistical, a simple logistical process, which makes so much difference to performance. It's really significant.
Yes, absolutely. And one argument people might have around this is, because we're talking about throughput here, you could have the argument of it's no good going faster if that just results in worse reliability, like more errors after deployment. But again, we know from our research and from Dora's research that doesn't happen. When you increase your throughput, and you're doing it through the capabilities of continuous delivery and DevOps, it actually increases your reliability as well, because the things you're doing to increase your throughput are things like automation. And automation is far better at completing your deployment checklist than, Dave in operations is. No offense to anyone called Dave in operations. It's a common problem. Following a checklist is not a great thing for humans to do. So we will just quickly skip past the model here. That's just a little reminder of what we were talking about. Lightweight change approvals, reliable deployments. That gives you better throughput, and we know that helps achieve your organizational goals. And we also think it's going to help you achieve your governance, risk, and compliance goals too. So they're not competing with each other. They're the same thing. And we'll summarize, because we're getting a bit short on time. Continuous delivery and compliance. Small, meaningful approvals are the way to go. They should be part of your deployment pipeline. Even if they're manual, you should have them integrated into your deployment pipeline, captured as part of those same tools. And you need to pool deployment rights. You don't want to have a single Brent who's in charge of your deployments. You want there to be multiple people. And that's kind of important as well for being able to handle deployments when someone's on holiday or if they decide to leave your organization.
Mm-hmm.
So that's our 3 reports that we've published this year. You can get them from octopus.com/publications. But we also have something exciting coming.
Yes.
Charlotte, tell us about this new report.
So I've been working on a report on AI, and everyone's doing it these days. So, it's not a new thing, but we just wanted to see, I guess, a number of things that think I thought was missing throughout the literature now. And so we wanted to really go deeper into AI integration. So I guess current patterns of adoption and the metrics involved. And we actually have gone quite deep into difference in usage patterns across experience level. So on specific tasks, which are really interesting findings there. Not so dissimilar about what you would expect, but a few things that were really intriguing. And then its impact on software development. So we've focused on constraints. So we actually do go into a bit of a deep dive into the code review constraint. And AI is able to really benefit and save time on all these other tasks around it. But all of that code just being backed up makes this code review process longer, just because of the value stream, I guess, management workflow. It's not really because it does make code review slower. It's just because there's more code coming through, and it's just sitting there until the senior developer gets to it. We also go into hiring trends, which I've found really fascinating, and the evolving talent pipeline. So I guess how some of the roles may be changing due to AI integration. What does that mean for skill development, particularly for junior developers that in the next 3 to 5 years will be expected to perform at senior levels? It's a lot. It's really interesting. I'm finding it very interesting.
So there's lots of stuff coming up in this report, and I am super excited to see that when it comes out. So what we'll do now is I'll say to those of you joining from Australia, thank you for staying up so late to join us. I've enjoyed kind of going through these findings. It's been a good reminder of all of the cool and exciting stuff that we found over the past year. And I'm also excited about our artificial intelligence report, and also our platform engineering report, which is going to be a really deep dive to follow up on that platform engineering pulse that we did. So thank you very much.
Oh, John, I think he was muted.
I was muted. Sorry. Doing a bunch of talking. Sorry. It's like 5 a.m. for me. I'm totally out of it. Sorry about that. Yeah, awesome stuff. Thank you to Steve, Matt, and Charlotte for that awesome report. I've got Kit and Liam here who are going to do a session entitled Verifying and Troubleshooting Kubernetes Deployments, a Practical Guide. Gentlemen, I think this is going to be very hands-on. Do you guys have slides? Let's go ahead and share those if we do.
Yep, I'll put that up now.
Perfect. I'll go ahead and remove myself, and then we'll add your slides. And as they say, away you go.
Thanks, John.
Oh, sounds ready with that. Thanks, John. You wouldn't guess, but today we're going to talk about practical guide for Kubernetes deployment issues. So let's start with who we are. I'm Kit, and I need to find the way to switch slides. Yes, here we go. So I'm Kit. I'm a product manager at Octopus Deploy, and we also have
Liam. I'm a lead cloud engineer at Octopus Deploy. Yeah, we're both from one deployment team.
Yes, and for the last few years, Liam and I have been working on everything related to Kubernetes features, integrations, how to install Octopus on Kubernetes, and this year we've been working on the RVCD integration. But that's not what we're going to talk about right now. Today, we're going to walk you through a real incident example, actual story, a battle story happened to Liam some time ago. We will use this example to show you how hard Kubernetes incidents might be. Not always, but sometime. We'll talk about the tools we used for the investigation of logics behind some decision made, Will you see some confusion that can actually happen between different people trying to see what's going on through their lens and their perspective? And finally, you'll see how the root cause was found and how essential a collaboration between different roles and different people involved in the incident was. This talk might be useful for, I think, everyone who wants to deploy to Kubernetes or run software on Kubernetes or just manage Kubernetes clusters, or everyone who just want to have fun listening to a real battle story. Okay, let's jump straight into that. We'll start this talk with just incident itself, what happened, how different people acted, and what they learned. Then we'll talk a bit more in depth about the framework. How would you approach this incident and how to build a better process? And we'll finish with Q&A if you have any questions in the chat. All right, so just a few words about Kubernetes deployments. Over the years, or the last few years, we talked to many customers, prospects and partners, and people develop different tools for Kubernetes. If we learned one thing from all those conversations, all those people, is that Kubernetes troubleshooting is not an easy challenge for everyone. Everyone struggles, everyone finds their own ways of doing things, everyone uses a bunch of tools. There is no golden or silver bullet, but I think we're getting there. Why is it so hard? So first of all, Kubernetes is absolutely a great tool. It's amazing in the way how it abstracts infrastructure from developers and makes life easy. Until the point that something breaks, and then this abstraction and this complexity might work actually against you. The thing is, symptoms you see, for example, as a developer, not always point to the root cause. You need to really dive deep into and compare different things to understand what's going on. Different roles could see different slices of the system. You don't have all the information. And, well, the person who sees the issue first might just not be the person who can fix it or has anything to do with the problem at all. All right, so it's time to talk about our incident. Over to you, Lee.
Perfect. So today I'm demoting Kit from being the principal product manager of the team that I'm on to being a developer. You're down to my level now, Kit. So today I'll still be the infrastructure engineer, thank gosh. I'm the one that'll be owning the cluster. I monitor the platform, and I'm also the one that gets paged when things go wrong, which is a little bit frustrating. Whereas Kit, he's the developer. Now, he's going to be owning the application, he ships features, and he sees code, but not always the cluster. So the scenario here that we have is a Node.js-based GraphQL service. It's called the gateway, and essentially it's a mediator. It takes in GraphQL requests. GraphQL, for those who don't know, is just similar to a HTTP API, but more complicated, pretty much. And that's all you really need to know about it. But you have this GraphQL mediator service, and it starts throwing DNS errors. We can see the error messages, and it's EAI again. Anybody who's seen that in production, number one, I'm sorry. Number two, in this case, is a temporary failure in name resolution. And then what we follow on from that is a day of investigation from two very different perspectives, mine and Kit's. So part one, the infrastructure investigation. First, I get paged. In here, it says at 10:33 a.m., but that's only because I made a test page at 10:33 a.m. to do this. It was actually significantly earlier in real life, which was lovely. But in this, we're getting paged because we're seeing DNS failures in Kubernetes 01 prod. So my first instinct, let's check the DNS infrastructure. Let's just have a look and see if we've got core DNS there. So I run kubectl get pods and just have a look at everything there. And core DNS there, everything's ready. Everything's fine. Ignore the restarts. That's just a bad screenshot that I took. Then I go through, run kubectl get logs, or kubectl logs. And I'm just going to have a look at just the latest logs because I expected there to be lots of logs. But core DNS and kubedns in general doesn't actually log out that much. It just says, oh, sweet, I'm running this configuration. I'm good to go. So everything's running, apparently. Well, yeah, everything does look fine. Maybe, just maybe, it's the networking. There are also meant to be emojis here, but it's stripped them out for some reason. So you'll get the idea. So the next thing that we do is we do a kubectl run, and this is just a debug DNS pod, right? So I'm going to go in and I'm just going to run ns lookup just off of some random pod. It's going to just double check that, we can see the accounts.production.svc.cluster.local. So that's just the accounts backend service in the production namespace. And still nothing. Everything's working. Maybe, just maybe, it's a capacity issue, because DNS can act very different depending on whether you are running, lots and lots of DNS requests through it or very few. So I take a look at Grafana. Now, this dashboard is built in to the Kube Prometheus stack that you can get into your cluster. It's there by default. And if you install the Kube Prometheus stack, you get a whole bunch of information like this. And then you can just ship it off to whatever you're using OpenTelemetry data collectors with. So heavy recommend getting this installed into your cluster if you don't already have it. But I'll go back so you can see. But like in there, everything is looking normal. Our query rates, our latencies, everything, perfect. Everything is normal. So just as a little bit of a last hurrah, I scale the core DNS deployments. I'm just going to give it more. Maybe that'll fix it. Spoiler alert, it didn't fix it. It did not fix it at all. So every infrastructure check is coming back clean. Realistically, the DNS infrastructure is healthy, the network is working, and other pods seem to be resolving DNS without issue. So I throw it over the wall to Kit. Take it away.
Thanks, Liam. So imagine being a developer. This is like a beautiful morning, quiet, I'm working on my code, and then out of nowhere, interaction engineer knocks on my door. Almost never good news, and that's not how I want to start this day. But that's happening. So Liam comes and start with, hey, you know what? DNS is broken, and it's broken only for your app somehow. I'm pretty sure it's a software bug. Tell me, Liam. So what might be, and from here on, it doesn't sound good, like at all. So my first reaction is, I need to understand what happened with the what I deployed recently. Was it a new version or maybe something else? So conveniently, we'll look Octopus screenshots here as example. So I look into deployment timeline just to see what is actually going on and did I deploy a new version? And yes, I actually can see the change. So moreover, I know this change. I work on this. And this change was just to add a local cache for the backend server schema. The thing is, this actually has nothing to do with the DNS. So DNS shouldn't be affected at all. So I need to dig a little bit deeper to just understand what I actually deployed and just check the manifest to see what changed in the version. Okay, what I see here is I didn't actually change much. The only thing I changed was the image, my contain image. So it shouldn't be a massive configuration change at all. So my next reaction is I need to go even deeper. So what I do, I'll open the pod logs. And yes, indeed, when I look at this one, I can see DNS errors happening in production. Okay, so definitely the thing is in production and it's not looking fun. But to confirm that it's actually my app, I want to look into test and dev environment, because if the change happened through all of them, I should see the same issues there. Surprisingly, when I open my test environment logs, I didn't see any issues at all. So looks like test is absolutely happy, but production is definitely not. So how could that be happening? This is my next question. So what I'm doing from here is thinking about the difference. Okay, I have a lot of people working in my production environment, and obviously test and dev might not have that load. So what if the thing is just connected to how many people using the feature right now? Okay, easy. I need to verify that by replicating the load. What I'm doing from here, I'm opening my tools and starting to put many requests in my test environment. And then I just sit and wait. What should happen next is, well, the load goes up, and within the next few minutes, I'll see a bunch of DNS errors, wouldn't I? But unfortunately, I actually see nothing. What happens in reality 10 minutes later is, yep, my server slows down a little bit, but no errors at all. I don't see any issues. Nothing what I see in production. Even when I add 10 times more load than my actual production environment, I still see nothing happening. So this has started to become really concerning. And I'm starting to think about, okay, maybe after all that, it's actually an infrastructure issue. At this stage, we probably need to start working together. Obviously, myself or Liam, we just can't resolve the issue individually. We need to bring our heads together and start working on the problem. Okay, the first thing I have in mind is I go to Liam and ask and tell him that I can't find any issues in the code. And moreover, I can't replicate them in tests. So what do we do next?
I mean, that's true, but there's no other DNS failures in the cluster, and you've interrupted my lunch. Thanks a lot.
Well, the thing is, I know as a developer that the only change I made was to add a cache, and that can't break DNS. But probably this is the time I actually tell Liam about it, about the change I made.
The cache, you said. Okay. Well, if we can't replicate the problem using the same code in test, let's have a look at the differences between test and prod. And this is also probably Kit's first time in hearing there's a difference between our test and prod environments as well, by the way. So in test, what we have is one replica of our pods and an SSD storage class, just because it's the default one there and we've only got one replica. But in production, we need to deal with a lot more traffic. We have 3 replicas, and we've got a shared storage class so that they can all use the same disk. This is interesting because is all of this really just to do with the shared disk? So I did some Googling. I actually think this is the exact same Google query that I used all the way back when this actually happened to me, which shows you what was going through my mind, where it's just DNS error, Node.js, Kubernetes, right? It's just shouting words at a void and trying to see what comes up. But I did find this really neat Medium article about how to fix Node.js DNS issues. And even in here, the author says that networking issues are the most challenging for them. And that is the same for everybody, especially when we're dealing with Node.js. Bingo. In the end, we tracked down what happened to a small bug. It's a little bit subtle until it hits you in the face like a brick. What was happening is the code that wrote the scheme cache, when it wrote to the shared volume, it locked it to write. But when there were multiple pods and they were processing things for the same service, they would both attempt to write at the same time. Then other things would try to read, and it would cause a deadlock. Bad things happened. And when the pods were contending to access that file, what was happening is there's a little thread pool in the back end of Node.js. It's called the UV thread pool, and it's by default has 4 threads. And those 4 threads are all Node.js has to work with asynchronous operations. So if a thread starts and tries to read a file and it's locked, that thread is now completely blocked until that file is able to be read. Now, unfortunately for us, in production, those 4 threads got completely blocked trying to look up that file. Something else that's asynchronous in this case, DNS lookup. Hooray! So our DNS lookups in production couldn't acquire a thread, and so DNS times out. Very, very lucky for me, at least as the infrastructure engineer, because this was a code problem. Except it kind of wasn't, because neither of us really had the full picture. I knew about all of the shared volume behavior, but only Kit knew about the new cache behavior, right? There was a little bit of a miscommunication here, or at least not a miscommunication. It's just I didn't know what the heck was going on in my own production environment. And Kit didn't know the differences between our testing environment and our production environment. So, as with all good incidents, I ended up running a retro on this to look back and then also to look forward. And what we ended up doing was changing our approach to failures quite a bit. Previously, what would happen is when an incident came up, engineers and well, specifically infrastructure engineers would take the call, they would have a look, they would investigate, and then if they found out it was a software problem, they would throw it over the wall to the developers, put it in their backlog, and that was that. But that wasn't going to work anymore. Not with Kubernetes, not with containerization. It's just too difficult. So what we ended up doing was 4 things. The first of which is involving developers early. These were the kinds of mantras that we were following from here on through, because we knew that developers had the most context. They knew the changes that were going in. And even if it is an infrastructure problem, it's usually going to be the intersection between an infrastructure problem and a software problem. And developers have that information. The next thing we thought we really needed was to make sure the deployment history was visible. As an infrastructure engineer, I didn't even bother looking at Octopus Deploy. And that is if you're even using Octopus Deploy. Getting a deployment history without a tool like this is actually surprisingly difficult, because you don't know if something's just deployed or what's changed and anything like that. So making it really easy for anyone to know what was deployed is super duper important. The other thing we tried to, well, maybe not force, but heavily encourage our developers to do was to document the dependencies. Nobody likes documentation, least of all me. But the seams between the hardware and software, like I said before, is where we see the most failures. So when software tries to access the network, or when software attempts to access the disk, these are the kinds of times where we need to be really careful and make sure that we're finding the right kind of amount of documentation to know when something is going wrong because of a change. You know, for example, this new change in caching behavior using the disk, or if it's something to do with the infrastructure that it's actually relying on. And then the last thing is you'll probably note that during this entire incident, nobody talked about just rolling back the code. And that's because at the time, it wasn't easy. You know, there's a whole bunch of kind of like manual things that happened. We had to downgrade the database because we'd done a DB upgrade at the same time, a bunch of things. There were codependencies. It was really hard. And so from here on through, we weren't just automating our deployments, we were also automating our rollbacks. Because in the end, realistically, your customers don't care about how you fix a problem. They only care about how quickly you can mitigate it. Now, in real life, this was like a couple of weeks of investigation. We made it sound really easy in here, and it's really easy in retrospect. But hindsight is 2020, and yeah, it was not an easy problem to investigate. So if we had automated rollbacks, we'd be able to have a much easier time, I think, investigating and fixing this problem.
All right.
So yeah.
With that, thanks, Liam. That was exciting story, truly. And with that, we got to the end of our talk. So let's quickly recap what we learned from this incident and what could we change next time. So just 2 thoughts on this one. First of all, community troubleshooting, Kubernetes issues, they span multiple layers, teams, and mental models. You can't just fight this battle on your own, and if you try, you will likely fail. If in your company, that's how we do stuff now in Octopus, you need to enable everyone to contribute their understanding of the system involved, or the code involved, on the actions they made to actually solve the issue together. You need to dive deep, you need to collaborate broadly, you need to solve problems with less stress, and as Liam said, ideally, automate. So, all those beautiful screenshots and thinking through and examples you can actually find in the blog post that Liam just posted yesterday evening. So amazing work, a lot of dedication to this one. So you can scan QR code and just follow the link, you'll find it there, and it's worth reading. You can also see all the tools to use in the process and all the just logical thinking through, so you can use this as a framework or just use a bunch of tools or just read it for fun. It's useful either way. We have a few more minutes, don't we, John? So if you have any questions in the chat, we can answer them, or we can just conclude this one a little bit earlier. Let's wait maybe for 5 seconds.
I was going to propose that we take a look at this blog post that you wrote here, Liam. So this is, it works on my cluster. I love the name, A Tale of Two Troubleshooters. So basically everything that you saw in this presentation is being obviously expanded upon here. And if you want to have a look, you can go ahead and hit that URL and share it with your friends and get some feedback on it, which is great.
Cool. And
yeah.
Just finally, Liam and I and all our team, we're actually really keen to hear your battle stories about Kubernetes, about deployments, about how you do stuff in your company. Maybe you find a way to visualize the issues better or trace them, or you use AI to help you resolve them faster now. So we'll learn from that, and we'll actually try to do our best to make our product better. So, or just have a conversation with you and share our insights. So if you want to share something with us and have a chat, we actually both are quite active in our Octopus community Slack. Yeah, John, if you can just for a sec get back to our slides, I'll show the link there.
Oh, sorry.
That's another one. Yeah, so we have a community Slack. If you join it, you can DM me or Liam, or you can just join our Kubernetes channel there, and where we can have a bunch of discussions about troubleshooting, and not just that, just anything Kubernetes related. So yep, please join and let's have a chat. Thank you.
Awesome. Yeah, the other thing that I was going to mention, Liam, you were recently speaking at KubeCon. So you did a presentation on application performance with eBPF.
Yeah, absolutely. So that's actually recorded. Hooray. Yeah, you can see. No, oh God, I don't want to see my face. Please don't. Stop it.
Come on.
No,
it's fine. There you go. Look at that beautiful
there
man.
we go.
There you go.
Here I am. So yeah, over here, I've gone through and done a quick talk about how modern deployments kind of does performance management for some of the components we're shipping into people's clusters, but being able to do that from like the point of view that we're not going to be able to see the metrics inside of those clusters. So this is about the Kubernetes monitor and yeah, how we kind of traced performance bugs in it before we even hit them in production clusters and stuff like that. So if you want a little bit more of insight into how we run things at Octopus and how we use some cool technologies to solve some novel problems, that's a nice little talk for you to view.
Yeah, that's awesome. I find it kind of overwhelming at times to just kind of understand the entire ecosystem around Kubernetes. It seems like there's just more and more tools all the time. How do you guys keep up with all the ecosystem tools that are out there? Because I know it's a vast ecosystem.
I don't think you can. to be honest, I don't think you can keep up with the ecosystem. But what you can do is focus very heavily on the things that you need, right? It's not worth just adopting a tool for a tool's sake. You should adopt a tool when and if you have the need for it. And so I found that there are lots of novel use cases for these tools. You're like, oh my gosh, I'm having issues with like the speed that my image is being pulled to my Kubernetes cluster. So, oh, okay, maybe I can use Harbor or Firefly to go and investigate that. And yeah, there you go. Look at that CNCF landscape. It's a little bit busy there. Oh, look at that. Containerd's there. Woo. No, but realistically,
Like, how do you keep up with all this? This is insane.
yeah. Again, you don't. You just kind of choose the biggest box there. No, I'm kidding.
You're at stage 5 acceptance.
But yeah, heavy recommend having a look at that. What John was just showing, which is the CNCF landscape. That has quite a lot of tools in it, and they're all kind of separated by the use cases that they have. Very, very useful tool to just have a look. But,
do you find when debugging Kubernetes issues that it always just comes back to base primitives? Like you guys were talking in your scenario there, maybe it's just a networking. It seems like it's always DNS. Is it always DNS?
Not always, but more often than not. And even in this case, it wasn't DNS. It was the UV thread pool. Again, one of the few times it wasn't DNS. But a lot of the times, yeah, it does come back to primitives. All in the end, whether it's deep down it's C groups, for example, having issues, right, or a whole bunch of these other kinds of core bits of Linux that goes wrong. Everybody at Octopus knows me as the Kubernetes guy, but realistically, I actually started as just somebody who was really interested in the Linux kernel, and it just went from there. So
there you go. Awesome. I won't pretend to actually understand the landscape as well as you guys. I try my best, but there you go. Any other resources that you guys would like to cite before we wrap up here? No?
I just look at Octopus blog posts. Actually, I just want to say, look at Octopus blog posts. I think for the last few quarters, we published a bunch of things about Kubernetes, starting from how we work on features, how we just approach our investigation, and how we learn about problems, to very practical guides like what being posted yesterday. So there are a few golden nuggets.
Yeah, if you want to find out more about this, you can go on to the roadmap. Look at this; it's getting hammered right now. It's getting so slow. Everyone's looking at the roadmap right now. Yeah, lots of stuff that we're shipping around this. We talked about this during the obviously the release party kit, the granular permissions for deployments via the Kubernetes agent, support for RBAC, etc. I always come in here just to see if you guys have snuck something in here that you didn't tell anyone about, anything around Kubernetes on the planned list. But
we just actually added one yesterday. Now you see this new
tell
card
us.
for Argo CD. Yeah, we just we shipped the brand new integration for Argo CD last month. I already have like a few dozen people using it, although it's actually still early access and got released for self-hosted customers just last week, as we talked. And yeah, we just added a few things just to show what we're thinking about, how we're going to improve it next, what we're going to focus on within the next quarter or two. And yeah, just want to invite everyone who is interested or want to use Argo, thinking about using Argo, or use Argo and want to share how bad it is or how good it is, just go there, leave a comment, and let us know what else we can do better. Yeah.
So the place you want to go is roadmap.octopus.com. Click on the planned section here at the top, and then you're gonna look for this little icon here. You'll see these two little friendly chaps high-fiving. So there you go. Sorry, could I interrupted you?
No, that's it. That's what I want to say. Just share the comments, let us know. Let's have a chat.
Awesome. All right, Liam, Kit, thank you very much for your presentation. Really appreciate it. We'll let you go.
Thank you.
Oh, sorry, just cut him off there. Sorry, that's a bit rude. Anyways, looks like we are continuing onwards. So let's go ahead and take a look at the schedule once again. So coming up next, after Kit and Liam, we now have this session by Mike and Andrew, otherwise known as Bessie. Save a canary, flick a toggle. Why we built Octopus feature toggles. So this is really cool, actually. If we go ahead and read the description, this is something that we're looking at, and I think you guys are going to find really interesting in this session. So let's go ahead and switch over to that.
G'day, Mike. How you doing this morning?
I'm pretty well, Andrew. How are you?
Yeah, I'm doing well, mate. I'm doing well.
Excited to be
be here at Shipped. Yep. Today we're going to present a talk together called Save a Canary, Flick a Toggle. And the story is about the evolution of our delivery pipeline. So we operate Octopus Cloud, right? We ship CD features to thousands of customers all the day after day. And over the years, our approach to rolling features out to our customers has changed quite a lot, and it's evolved along with our products. And that's evolution is really what we're here to talk about today, right? We'll talk a bit about our design decisions, some of our key learnings, and ultimately we'll talk about why we built Octopus feature toggles. So my name's Andrew Best. I'm a senior principal engineer here at Octopus. I work in our foundations group. How about you, Mike? I might hand over to you now.
Yeah, thank you. My name's Michael Richardson. I'm a product director at Octopus. I live in what we call our deploy group. We build a bunch of the CD type functionality. Should we dive in?
Yeah, let's go. How should we get started today, Mike?
Well, I reckon we start with the punchline. Let's cut to the chase, as they say in the movies. So we're going to start by releasing an actual feature, just like we would on any given day, to show you what it looks like for us when we ship features to Octopus Deploy. So with that, I'm going to jump to here. And so this is our internal Octopus instance. This is what we see. This is what ships Octopus server that you use. And today, we're going to dive in here. And you might notice there's a new tab on here that you may not have seen before called Feature Toggles. And we're going to jump in here. The feature that we're going to release today is a feature called Project Templates. This is not at all the topic of our talk, but in the spirit of never missing an opportunity to be pitching, I'll give you the quick 10-second overview. Project Templates is part of our Platform Hub offering. It will be when we release it sometime next year. And it's designed to allow you to standardize entire Octopus projects. So if you have 50 microservices that all look exactly the same and you want to ship in the same way, you'll be able to base them all on the same template, and you'll be able to receive updates to that template. And yeah, it makes onboarding new teams as simple as a few button clicks, and they'll be up and deploying. Really cool feature. But like I said, it is really exciting, but it's not at all the topic for today. Today, what we're going to do is release this feature. So it's in development at the moment. So it's hidden behind a feature toggle, which is how we build things. And I am going to ship it to my internal Octopus instance. Well, when I say internal, it's actually a production instance, just like any other one. It just happens to be my instance. And so I'm toggling this feature on for that. Before I do that, I should show you there's nothing up my sleeve here. So this is this instance. You see I'm in Platform Hub, and you'll see you've got process templates, we've got policies, which is lovely. But what I really want is some project templates. So let's ship it. That is done. And if we jump over here now and refresh, project templates. Ta-da, simple as that.
Oh, so easy. That's so easy.
So easy, right? I will jump back to my slides here. Sorry, got windows everywhere. And yeah, so that is how we ship a feature. And so that's very similar to what we will do when we come to ship this for real to our customers. We might roll it out to 5% of them first, but we're going to talk a little bit about that coming up. But yeah, that's it. Lovely, amazing, right?
Was it always that easy, Mike? Has shipping just been, just flick a toggle and all of our customers get great new stuff?
Right. So this is where we need the big record scratch sound effect, don't we, John? Can we add that in post-production, please? A big because no, it definitely wasn't always this way. The purpose of today's talk actually isn't for us to brag about our release process. Like everyone, we very much consider it a work in progress. What we want to talk today about is our journey towards that progressive delivery. And so there are two major components to progressive delivery. One of those is canary deployments. The other one is feature toggles. And we're going to talk about the various iterations that we've gone through of both canary deployments and our feature toggles offering, and ultimately why we decided to build feature toggles as a feature in Octopus. And with that, I'll hand back to you, Andrew.
Yeah, cool. Cool. Let's go on a bit of a journey here, and we'll start talking about the early days, where we were before. So flick the next slide, Mike. So Octopus started life many years ago as a self-hosted product. This little purple guy here was our logo many moons ago. Mike, you were around when this guy was our logo, weren't you?
Oh, come on. Haven't been here that long. No.
Our art skills have evolved along with our products over time. And this was also, so it was a simpler time for our logos. It was a simpler time for our delivery pipeline too. So engineers would merge features from feature branches. They would work on them until they were satisfied. They would merge them into main. Our delivery pipeline would kick in, and within an hour or two, those features would be available on our website for all of our customers to download and install. And that was basically it. It's very straightforward. And this worked really well for a time, right? We could put new features into customer hands really quickly when we needed to. We could be agile, we could be fast, we'd ship early and often. It's a great way to evolve the product. Now, some time passed and Octopus became a bit more complex, started adding sort of more features to it. And the product grew in capability and complexity. And as it did, we started encountering more quality issues, as you do when software becomes more complex. So we had this sort of climbing change failure rate that we were trying to deal with. And when our customers encountered issues, time to recovery was something that we would struggle with from time to time, because the nature of self-hosted software is we're not in control of that last mile of the delivery pipeline, right? The software is up on our website, but it's really up to our customers to download and install it and to manage the actual sort of deployment of the software into their environment. And so time to recovery at times was not something we were satisfied with. It could be, it was beyond what we were comfortable with, and so it was growing as well. And so the combination of these two things were becoming a bit painful. We were longing for more safety and control in our delivery pipeline. And fast forward a little bit, then comes Octopus Cloud. And it seemed logical to us at the time that we would use our cloud product to improve our product quality and to help solve this problem. And we'd do so by shifting to a progressive delivery model. It's important to understand in the architecture of Octopus Cloud, every customer gets their own isolated Octopus instance, which is great from a product perspective. It gives our customers a number of benefits as to sort of the isolation of their instance and the protection of their data and things like this. But it sure does make deployments a bit more challenging, because you're not just deploying one thing that all of your customers inhabit, you're deploying thousands of things, and all of your customers inhabit those. And so in this new progressive delivery model that we'd imagined, we'd first deploy to ourselves and our team, our inside instances. You saw Mike's instance before as a good example of sort of insider instances that we have. We deployed to some early adopters that we had, and then eventually the changes would make themselves out into the broadest environments where all of the rest of our customers were, and then into self-hosted. Conceptually, we pictured this as a set of rings like you see here. We called them cloud rings, and these were modeled as environments in Octopus ultimately. And each ring would bake for a short period of time. And the model might be very familiar to some. We could call these cloud rings canary rings, and it would be very similar in the concept. The idea is we deploy a set of changes to fewer customers to start with. We give it a little bit of time to see if we can get signal as to whether the quality of those changes is sufficient. And once we're satisfied that it is, we propagate those changes to downstream, higher impact, more populated environments. And so if something does go wrong, we catch it early, less people are impacted, we can fix it really quickly, and we can get on with life. And new release will go out the door. So that was the hypothesis. Letting changes bake for short periods in these canary environments would let us catch these bugs earlier. We would reduce change failure, and we would drastically reduce mean time to recovery. That was
Makes sense to me.
After. Yeah, that was the idea. And so what we've got here is what we ended up with in Octopus. This is once again is a snapshot of our Octopus server deployment dashboard here. And at the very left, we have some automated testing environments. And then once we get to production, we start this process of baking changes in these rings, these concentric rings or environments in Octopus,
until eventually the changes go out the door to GA, which is our self-hosted environment. And this is where it might look a little different from your typical sort of Facebook style canary deployment. Now, Octopus doesn't enjoy the level of traffic Facebook or Google does, right? Your average Octopus instance, right, Mike?
I wish we did. Yeah, one day.
Yeah, it would make our lives much easier, but it doesn't. We can't deploy changes for 30 seconds and generate sufficient signal that those changes are healthy or not, and decide on that whether to roll back or forward. So we need to wait. Our hypothesis is that we needed to wait a little while. We needed to give the software time to be adequately utilized in one of these canary environments before we would propagate it onto the downstream higher impact environments. So we get some signal as to whether it was healthy or not. So we would bake these changes for 24 hours on our own production instance, and then for a few days on our staff instances like Mike's, 7 days in early adopters, and then they would be out the door to everyone else. And to make this happen, we needed to develop a few specialized components that would complement our sort of core capabilities in Octopus and allow us to achieve this delivery model. So the first of these components is a thing called the enthusiastic promoter.
I love this name.
Yeah, it's good, isn't it? So the idea behind the enthusiastic promoter is that as soon as a change hits main, if everything goes well, it should make its way out the door to all of our customers without a set of human hands touching it. So it's the thing that allows us to make our progressive delivery continuous delivery. And the promoter itself is just a small CLI tool. It's a .NET tool that we built that promotes releases as long as a set of criteria is satisfied. And these criteria are things like, is there a newer release I should be promoting? Is there an open issue with this release, and should I not be promoting it? Is it the weekend? Is Mike on call at the moment? Can we deploy these changes now? It's kind of like life cycles on steroids. It's tailored to suit our particular business rules and needs. It'd actually be really neat if some of these things we're presenting today make their way back into the products. And it's pretty typical, right, Mike? We do this a bit.
Yeah, absolutely. We often see this. We sort of write something that fills a gap, and eventually it becomes a product feature, like we're about to see actually with feature toggles.
Yeah. So we run this CLI tool in a runbook. The runbook runs every 5 minutes, and it decides whether it should promote the release onto the next downstream environment if it's ready to go. Now, when we have this enthusiastic promoter or this enthusiastic machine that wants to progress changes along continuously to all of our customers, occasionally something might go wrong. And when it does, we need to be able to stop that machine. And the reason we want to stop the machine is so that we can do investigation and remediation when we need to.
We need to dampen its enthusiasm a little bit.
Yeah, that's it.
Yeah.
I think at some point we were thinking about renaming it the cautious promoter to sort of, put it to infer that. But anyway, the end-on cord, the idea behind this system was that when you pull the cord, the enthusiastic promoter stops. So anyone in the company can pull this cord. It's a well-known system. You can go to it, you hit a button, and the machine stops essentially. And there's a message that goes into Slack, and everyone gets a bit of a chance to breathe, deal with the problem, investigate what it is. And if something is actually wrong and we need to go and remediate it, we need to patch or bug fix or do something, then we can also taint a set of releases to say, hey, the enthusiastic promoter should not promote this set of releases because they contain a defect, and we've patched it here. But this set here shouldn't go out the door. So it plays sort of two critical roles there. And the final thing in our list was feature toggles. But this wasn't the awesome auto on suite feature toggles Mike demoed before. These were the feature toggles that many teams start with when you're building software. They're basic code constructs that are driven by environment variables in the host environment. And so this allowed us to toggle features on and off in our application. But the downside to them is we needed to restart customer instances for them to take effect because we wanted them to remain stable for the lifetime of the process. And we could only restart customer instances in our cloud environment when there was a scheduled outage window. And the reason for that is we don't like interrupting customer deployments. You know, deployments are not CI, right, Mike? We can't just kill deployments like you can kill builds.
No, not quite as immutable as a build, unfortunately.
Yeah, the last thing you want to do is to kill a deployment when it's halfway through thousands of tenants and have to sort of reconcile the state of the world at that point. It's a bad time.
Absolutely.
Bad time. So we value that uptime highly. We don't want that interruption. Given this, they weren't widely adopted by teams because teams would generally preference just patching and rolling forward, because what ended up happening was, since you had to wait for the customer outage window anyway, the mean time to recovery between patching or toggling the feature was about the same, and people just ended up preferencing it's not the bug fix that usually takes the time, it's the investigation. The bug fix is pretty quick to apply and then to roll out. So we usually ended up just patching and rolling forward. And at this point, you might think, well, aren't we talking about canary environments here? Shouldn't we be doing rollbacks when we detect issues? Rollbacks are challenging in software that deals with databases or any type of state. As soon as you deploy a new version of software that changes the way that your state is stored or expected to be, rolling back to a previous version that expects your state to be in a different shape is actually a really challenging thing to do. And there's patterns that allow you to do it, but at Octopus, we've made a conscious choice not to incur that cost and instead to lean into rolling forward to fix issues. So we developed this set of specialized tools and we had this hypothesis, and what we thought we were going to get was a modest increase in chase lean time, because as we said, we had these canary environments, but due to the nature of our software, we also had to let it bake for a little while in each of these environments before it propagated out. And what we'd hoped to see was a drastically reduced change failure rate and time to recovery. Particularly the time to recovery here is important. We thought, hey, we're going to catch issues really early, we're going to fix them, and then we're going to roll out new versions of the software that have been corrected that won't have those issues in them. So by the time it gets out to all of our customers, we'll have a much higher quality product.
This is going to be a short presentation if the next slide says this is exactly what we got and we're done.
Yeah, that's right. And everything was great, and yeah,
we can all go home.
Yeah, that would have been ideal. However, that is not what we got. What we actually got was a substantially increased lead time for reasons I'll go into on the next slide. But it's also questionable as to whether we derived any benefit as far as change failure rate and time to recovery goes. And the reason for this was what ended up happening, what we found after running this pipeline for 6 to 12 months, was we either hit problems straight away, and we found them as soon as they hit our internal instance. It was like, hey, this thing is off and we need to fix it. Or we found the problem once it had rolled out to all of our customers. And there was almost 0 times we would catch these issues when the software was sitting in these canary rings or these canary environments. And on reflection, it's kind of a reflection of our software. This is, if you can hold Octopus in a lot of ways, right, Mike? It's really powerful and flexible. And so quality issues surface in unpredictable ways. Sometimes you actually have to deploy the software out to a very large cohort of customers, and for it to hit the customers who's holding Octopus in a very specific way for a quality issue to the surface, and for you to then know that you've got a bug to deal with, just in case it hits other customers as well.
It's also a fundamental thing where our biggest, most risky customers are right at the end of that rollout pipeline as well, because they're also the ones that we don't want to hit with the early rings.
Yeah, right. But it turns out they're the ones that encounter these problems because they have such sophisticated and complex deployment environments. They just, they've got gnarly complexions of how they hold Octopus's features. So, what was going wrong? This is a bit of a complex picture, but I'll try and walk us through it. So at the bottom here, we've introduced a change, this red bar, that contains a defect. And it's rolling out the door from PR merged across the x-axis here. It gets deployed to our staff instances, early adopters, stable. as it's rolling out along that x-axis, we're accumulating new features on the y-axis, right? We don't stop building software just because we're shipping something out. We keep integrating new features into main, and they start baking and working their way through the environments as well. And then 11, 12 days later, once it hits all of our customers in our sort of cloud customer environment, we find a defect and the core gets pulled. We investigate it, we issue a patch, we deploy the patch right out to everyone. The patch only contains the bug fix. It doesn't contain any of these new features. What happens then, although, I mean, it took us a very long time to find this bug, which is one problem, but what happens after this is the big problem. Now, we've got this big batch of changes here. It's about 10 days worth of PRs. We were shipping at this time in 2023 about every 10 days, we'd ship about 100 PRs, Mike. And so you had 100 PRs worth of changes that all of a sudden, they contain the same defect, right? They're not sitting there in isolated branches. We practice continuous integration. And so, you know, they've all got the same defect. So we have to stop propagating those and then issue a new release that contain the bug fix and all of these new features. And guess what happens once that big batch of features reaches our biggest customers?
It's higher risk. It's got a whole bunch of changes in it.
That's right. It might have another defect. And when that happens, you go through the same cycle again and it compounds. And sometimes you end up with embarrassingly long lead times, like it's quite bad.
So the irony here is that we implemented progressive delivery hoping to get smaller batch sizes, and what we actually ended up getting was effectively larger batch sizes to the later environments.
Sometimes much, much larger, yes. So the hypothesis completely fell through, and we were almost getting the opposite of what we had hoped to get out of this setup. So what needed to change? Now, there was a point here where, you know, we were getting this feedback, and it was, you know, developers were expressing that they were dissatisfied with, like, why is it taking my changes so long to get out to customers? But it was actually quite challenging to point out what the specific problem was. And we had to go and crunch a bunch of data so that we could point at this fact that where we were catching bugs and we were getting no value from these canary rings, right? And so we needed to simplify it. The canaries, as we'd structured them, they weren't working for us. We needed to remove these cloud rings, still have some progressive delivery, but drastically shorten that lead time. And then we would tighten up that mean time to recovery, shrink batch sizes, shrink change failure rate, shrink lead time, and everyone would be a lot happier. And this brings us to this somewhat counterintuitive point here where going faster will improve product quality. Now, this is something when we propose this change. So we've got this internal process at Octopus where we issue written RFCs when we're going to make, you know, significant changes to our product or our delivery pipeline or our processes. And it allows you to gather a lot of feedback across, across our organization as to whether people are on board with the change and, you know, whether things needed to be different. And what we actually found that even though the delivery pipeline was causing a lot of pain, a lot of people were really worried about removing those canary rings, weren't they, Mike?
Yeah, I think without the data to back this, it seems quite contentious, right? We're taking away safety nets.
People were like, that's what keeps us safe, right? That's where we catch bugs. But it wasn't like this. It wasn't at all. And so we needed to move to shipping smaller batches more frequently. It also means the whole diagnosis and recovery process is simpler, right? Smaller batches, it's much easier to bisect the changes that are in there, figure out the change that introduced the defect, fix it, move on, we're happy. So our data backed up this change 100%, and we needed to move on.
Our canary environments weren't paying for themselves, basically. They weren't justifying the complexity of being there.
Yeah, absolutely not. They were not pulling their weight. So we made this new proposal. We're going to go faster. But you remember, if we zoom right back to the start, we were moving fast, right? And we had this other problem. We lacked safety and control when we were deploying changes down. We didn't want to sort of take 2 steps back and end up where we began with. We wanted to move forward, wanted to roll forward, so to speak. So we wanted to move fast, improve product quality. But when there's issues, that do arise, we want to control them so that we can intervene, recover quickly with calm and order. How do we do this? We decouple deployment from release. So what we want to do is we want to deploy fast and often. We want features to keep, the enthusiastic promoter to do its job and keep shunting software changes out the door and then getting deployed to customer instances. But then the flow of releases, of feature release, is controlled by humans, like Mike demonstrated before. Once we're ready and we know the software is in a particular state, we hit a toggle, the feature turns on, we look at our observability, we understand whether it's healthy or not. And in this way, rather than like 2 customers or a handful of customers using the software and us trying to get insight from that, it would be rolled out potentially to all of our customers or quite a lot of them. And we'd have a lot more chance when we turn the feature on of diagnosing a potential problem, reverting, flicking off a feature toggle and being able to intervene. Now, we developed Octopus feature toggles to solve this. And they're also complemented by the and-on cord still. So it's important that we can still pull the cord and stop the enthusiastic machine and investigate the problem. So you don't just flick a toggle off. It's a poor customer experience for things to appear and disappear in the middle of them being used. But what we want to be able to do is stop the machine, do some investigation, and if the remediation is, we can just flick a toggle off and that'll recover and we'll go solve the problem, at our leisure afterwards. That's the best, that's how we want to recover from problems. That's ideal. So these 2 systems are really complementary. Now, and so at the end of the day, we developed Octopus feature toggles. They take effect instantly when they're toggled, and we can recover in seconds instead of hours or days. Now, Mike, do you want to talk now a bit about where we are today?
Yeah, absolutely. So yeah, let's time shift back to now. John, can we have the time travel sound effect, please? We showed a little demo at the beginning of how we release features today, and let's drill into a little bit more of what's behind that. So there's a bit of a recap. Where are we today? As Bestie was explaining, we've collapsed our, I guess you could think of them as canary rings down. So the way we ship today, we release internally to our internal instances. This is our dog food environment. We then, after a couple of days there, we progress this to our Octopus Cloud customers. And we initially ship to 5% initially. That's our first canary ring. And then, again, we let it bake for a couple of days, and we ship to then 100% of Octopus Cloud customers. And at some point in the future, assuming that's stable, we eventually cut a self-hosted release. So notice that that's a truncated version of the canary rings that Andrew showed on an earlier slide. And am I correct in saying, Bessie, that we're considering collapsing this even further?
Yeah, we're getting signal, after we've had this shortened model for some time now, that we think we can cut these canary bake times in half again, and we likely still get all of the value we get out of those canary rings. Now that we have sort of the feature toggles there to control the impact of the flow of changes, and we've decoupled that deployment and release, we're pretty comfortable with really sort of shortening that lead time and shipping really quickly.
I love the fact that we're optimizing this basically based on data, right? We're just checking what's the optimal here, the optimal amount of bake time to catch the majority of the errors. So this is an automated process. This will happen with no human involvement. So you used the phrase humans in the loop earlier, and we have 2 places where humans are in the loop. One is this and-on cord down here. So if at any point somebody detects an issue along the way, we can pull that and-on cord, and that will prevent that release from continuing to roll out until the issue is resolved. The second place where we have humans in the loop is these feature toggles. And as Bestie mentioned, we've moved from our internal home-rolled feature toggle system to something that we're actually going to build into the product. And that's what I want to talk a little bit about now. So why did we build Octopus feature toggles? This definitely wasn't our first instinct. We initially built a very simple environment variable-based toggling system, similar, I suspect, to what many of you have either built yourselves or used at places that you've worked. But as we said, this actually didn't give us what we needed. Most notably, if we found an error and had to roll it back, so toggle the feature off, we still had to restart that Octopus instance, which completely blew out the time to recovery on those issues. defeating the purpose of having the feature toggles. And so we also looked at some off-the-shelf feature toggling systems, so commercial products, to be able to do this. Again, they didn't quite fit our use case, and mostly that's because they didn't have that knowledge of Octopus environments and tenants baked into them, because this is how we ship. It makes sense, right? So the final point was, from a product vision point of view, we've always felt that feature toggles are a core part of continuous delivery. We rely on them very heavily, and we want to advocate for them as part of a continuous delivery pipeline. And we think they're a really natural fit in Octopus as well. And so we built it.
I think just sort of adding to that point about the commercial solutions, Mike, what we found was a lot of them end up wanting to toggle on features in a very user-centric way, right? Like they want to turn them on for cohorts of users, or users who are matching particular,
Yes,
patterns or labels that you can attribute to them through your software. And we don't really do that in our delivery pipeline. We want to turn on features for our customers. And it doesn't make a lot of sense to turn on features for percentages of users within our customers. We just want to turn it on for a customer, or turn it off for a customer.
Yeah, and I suspect people watching may have the same situations. Like for us, Octopus is a collaboration tool. It makes no sense to enable a feature for one user if the other user in their team can't also see that feature as well. It's also an automation tool. It makes no sense for one user to see a feature that then results in a workflow that no one else can understand how that workflow is configured, for example. So it's very much account or license-based rollout for us. So I thought I'd show you this slide because I think it does this screenshot is configuring a feature toggle, an Octopus feature toggle, and it shows just how deeply embedded they are with the Octopus ecosystem. So you can see you toggle a feature on and off for an environment, which hopefully makes a fair bit of sense. But the other really an interesting point that we've learned, and customers as well, is that often you want to toggle a feature toggle on, but only to take effect once a environment. So the classic example here is there's an issue with the feature, so you toggle it off, you ship a fix for that. You want to toggle that feature back on, but you only want that to take effect once the release version that contains the fix hits that environment. Otherwise, you're just re-enabling the feature with the same bug in it originally, or someone has to sit there and watch that release progress through the environments and time the feature toggle. It's much easier just to be able to say, toggle this back on for this release version. And of course, Octopus knows intimately about releases, so this is really natural. You can also see here, you can absolutely configure feature toggles for tenants. So you can turn a feature on for specific tenants, exclude it from specific tenants, which is really interesting as well, and even roll it out to a percentage of tenants, which is exactly what we do and how we ship. The other thing, the decision that I think in hindsight we're really happy with as well, is we based Octopus feature toggles on a library called Open Feature. If you haven't seen this before, I definitely recommend you check it out. This is a CNCF project. It's an open specification, as the text here says, that provides a vendor-agnostic, community-driven API for feature flagging. The mental model here, think open telemetry, but for feature toggles, basically. And the advantage for us is that we get a well thought through designed SDK that has clients for all the popular programming languages, Java, .NET, Go, TypeScript, just about anything else you can think of. The advantage for you as consumers is you get no vendor lock-in. So I'll show you actually on the next slide here. This is what it looks like from I guess a conceptual point of view. So your evaluations in your code take place against the open feature SDK, and you just configure the actual feature toggle provider as a provider model in that. So in this little code sample here, it says your provider of choice. In reality, you would use Octopus feature toggles there, or Launch Darkly, or your own home rolled system, whatever you have. And what that means is that if you, say, start with Octopus for your feature toggling needs, and at some point in the future you decide you need a more fully featured feature toggle service, swapping over to that becomes as simple literally as one line of code change. So the rest of your application isn't tightly bound to the provider, which I think is lovely. So I think it's time for a little bit of a summary here. So what have we got now? You saw the journey over time. We went basically from a very short change lead time when we would effectively YOLO changes into production. We implemented from there a whole lot of canary rings and drastically increased that lead time. Where we've landed at the moment is we've accepted a moderate increase in the change lead time. We still have canary rings there, as you saw. We have some bake time, and we've I guess achieved a moderate reduction in the change failure rate as well. Because depending on how you measure it, progressive deployments don't actually necessarily prevent failures. They are just a mechanism to be able to recover from them quickly. And that's the big thing that we've gained here, is we've gained a fast time to recovery. With using Octopus feature toggles, we can now toggle features on and off instantly. So errors and defects ultimately will happen, but the important thing is how you can recover from them, because this is what actually limits the number of users that experience any of those issues. Right,
Yeah,
Bessie?
that's the big thing, right? Like, it's the whole, if a tree falls in the woods and no one's around to hear it, does it make a sound? Like, if a defect happens, but very few customers experience it, does it, is the impact that great? So it's that time to
Exactly.
recovery that's really essential.
And with that, I think we'll talk about a few of the key takeaways that we've learned on this journey and hopefully are applicable for you as well. I think the first is that, as much as it's challenging, progressive delivery is actually a win. It improves the experience for your customers and for your team's shipping. Our customers experience less errors than they did before we implemented this, and our development teams ship more often and with more confidence now, thanks to the progressive deliveries that we've implemented via canary deployments and feature toggles.
Yeah, 100%. Now, canary deployments are a nuanced things, right? As we've learned here, we went in with best intentions, thinking, hey, we'll use these canary rings to sort of try and eke out the problems in our software before they reach the bulk of our customers. The nature of our product means they just didn't work for us. And so we had to retool and sort of refocus on what's really important in our delivery pipeline. So if you are thinking about progressive delivery and canary deployments, think about how they might apply in your particular context and scenario.
Absolutely. I think the point we would make is that canary deployments and feature toggles both have a really important role to play in implementing progressive delivery. They have different strengths and different weaknesses as well. So to get the speed and control, the combination of both is really powerful.
And always make sure to measure if you want to understand what's going on in your delivery pipeline. As I said, we weren't actually clear on what our problem was until we started measuring certain things and came away with insight as to where the problem lay. People were sort of unhappy that the developer experience wasn't great. People were unhappy with lead times, but it wasn't clear where in our whole overall pipeline setup the problems were. And that meant we didn't know what the solutions were too. So most businesses that deal with software have surprisingly complex delivery, continuous delivery needs these days. Deployments are not simple things. And there may be, areas that you can improve where, your current status quo that exists if you just sort of measure what you've got and sort of take stock and see how you're stacking up.
There is no one size fits all for progressive delivery, right?
Nope. Yeah, don't believe what Google and Meta tell you.
The final point here is you've seen us a few times in this presentation refer to Octopus feature toggles. And if you're interested in these as a feature, then stay tuned because they're coming as a public alpha early in 2026. So there's a card on our roadmap for this. And if you're interested, please go along and subscribe to that card and register your interest and stay tuned. And with that,
yeah, we'll toggle the feature on for you.
Shipping feature toggles with feature toggles. It's very meta, isn't it?
That's it.
I think with that, we're going to say goodbye, aren't we?
That's it, Mike. Thanks. That was fun.
It was indeed. I hope you enjoy the rest of Shipped, folks. See ya.
See you all.
All right. Sorry about that. Some minor technical issues there with the stream. We are back on track. And I can see that we have our next speakers up on deck. Let me go ahead and just invite them to the stage. So, just looking at our calendar or our schedule now, and take a look at the next session we have. We've got Kit and Robert, who are going to be doing a session entitled GitOps Meets Continuous Delivery, Patterns to Automate and Scale Software Delivery. So let's go ahead and add Kit and Robert to the stage. Hello.
Hi, John.
Hi.
Morning.
Morning. Do you guys have slides? Yes, you do. Let me go ahead and add those. Perfect. The stage is yours.
Cool, thank you. And that's me again. So today, Rob and I, we're going to talk about continuous delivery and GitOps. We will cover some patterns, just share our thoughts about how you can automate and scale software delivery if you use GitOps, and if you need continuous delivery with GitOps at all. And yeah, we'll just also share our journey, why we even thought about this problem in the first place. But first and foremost, who we actually have for the talk today. So, Rob, you go first.
Yeah, thanks, Kit. I'm Rob. I'm one of the principal engineers at Octopus. I work alongside Kit in developing and thinking about how we deal with these kind of modern deployments of engineers today. And yourself, Kit?
And I'm Kit. I'm a product manager at Octopus, working with Rob for several years now. For multiple years, we've been working on Kubernetes and Octopus, everything related to Kubernetes features, deployments, live status, and even we contribute a little bit to how you run Octopus on Kubernetes. So this is basically our sphere of interest. For last year, maybe now a bit more, we've been also working on the integration with Argo CD, the GitOps tool, and today we actually mostly for today's talk, we mostly use our experience through this like year and a half journey, plus also like contributing from the whole Kubernetes path we have. So when we were working on Kubernetes, we just happened to talk naturally to a bunch of customers and prospects and partners about the best practices and challenges, what they do, why they do stuff the way they do it. And no surprise, in most of those conversations, GitOps surfaced as the framework people use, tools they use, and also people brought a lot of challenges with GitOps to us, something they didn't really find a way to do or weren't happy about. And yeah, almost every conversation we had about Kubernetes ended up talking about GitOps. And it's not a big surprise. GitOps is a great framework. It suits the declarative nature of Kubernetes perfectly, and it was developed for configuration management. So everything is configuration in Kubernetes, so why not to use it? It's extremely popular. Some conservative reports and surveys will give you numbers about 30-40% of companies using Kubernetes also use GitOps. In some other sources, you find numbers like 60 or 70%. So we can probably say that every second company now deploying to Kubernetes would use GitOps in some capacity. But at the same time, being so great, GitOps also introduced certain limitations. And what we learned, those limitations often come when you talk about deployment automation, not just infrastructure management. So unsurprisingly, if you deploy software with Kubernetes and GitOps, you have a lot of other needs beyond just deployments. And this is what we're going to talk about today. This is the gist of this talk. So we'll dive into this problem space and talk about what GitOps is, what CD is, and why, what tools you have on the market to solve those problems, and how we approach it in Octopus. So this is like a little bit of a journey into our learnings and like how we build stuff. So, but first and foremost, let's start with an intro. So what Kubernetes and what CD is, what GitOps is, and why would you use them? Before we go there and I hand over to Rob, I want to have like one disclaimer. So we here talk about GitOps, but when we talk about it, we will commonly refer to examples from the Argo CD world. And that's because Argo CD is just by far the most popular GitOps tool. That does mean that all of this knowledge and thinking is not applicable to other tools like Flux, for example, or something else. But yeah, we just use Argo CD as the most popular shortcut. So yeah, let's go into that. Rob, over to you.
Awesome. Thanks, Kit. Yeah, it's interesting, right, that a lot of people seem to get into this world of GitOps and forget about continuous delivery or get confused about them. So let's first work out what these concepts actually are. So continuous delivery. Continuous delivery is a specific DevOps practice, and its core mission, its core sort of reason for existing is emphasizing the idea that you want your code always to be ready to ship to production at any point in time. So it's fundamentally, it's about reducing all that risk that comes with deploying to production. Key part of this is automation. Automate, automate, automate. You've probably heard that before. And it's about bringing the pain forward. The idea being that all the processes and steps that you go through when you're actually shipping to production, you want to go through that as early as possible. Now, if you ship, the longer that feedback takes, the more expensive that those mistakes become. So you want to create those really short feedback loops and learn as early as possible about bugs. Continuous delivery, it's often sort of talked about in relation to these other concepts, continuous integration and continuous deployment. Continuous integration is really just a sort of a subset of continuous delivery. And it's talking about ensuring that you get your code integrated into the sort of mainline code base as often as possible. Idea is to ship small pieces frequently, because again, the smaller the changes are that you're making, the less likely that you are to run into problems. Continuous deployment on the other end of the scale, that's about getting those changes shipped all the way into production. That's kind of that one step forward from continuous delivery, but it still really encompasses that idea of repeating that deployment process again and again in an automated way. Continuous delivery has really been common in engineering. It's been a common engineering practice for the past few decades, right? So it's not a new concept. I'm sure a lot of you are used to sort of automating parts of your process, but it's just, I think the way it's interpreted is changing a little bit as we kind of start picking up new tech stacks. And I think there's been some of these kind of basic concepts that have been lost. The key is that you want to rerun that release process as often as possible. So let's have a little look a bit deeper about what that release process is. So when we look at that one little box in there, the release itself, I want you to keep this diagram in mind, right? So the actual act of updating the application, that's just one small piece of the flow. In whether you're deploying to dev or staging or production, you still essentially want that application out in the world to be updated. But there's a lot of other processes that go around that. So it doesn't matter if you're deploying to VMs or serverless, or with GitOps and Argo CD these days, the same applies to Kubernetes. The idea is that application update is one step. There's many other parts that are involved. Some parts of it are repetitive. So for example, we're always going to be wanting to run, let's say, smoke tests against everything, or maybe you're doing blue-green in staging and then doing blue-green in production. Again, that speaks to that repetitive motion that we discussed earlier, helps to kind of reduce the surprises that come from it. At the same time, though, there's parts of that flow that might be specific to that stage itself. So maybe you're doing manual approvals or like using ITSM approvals in production, or maybe you're doing ephemeral environment provisioning in dev and it deprovisions once that deployment's completed. So the idea being that in this release process, there's parts that are repetitive, there are parts that might change across environments, but there's fundamentally parts of that are more than just the application being updated itself. Next slide. So we talked a little bit about CD. Let's have a little chat about GitOps and what it is and how it fits into all this. GitOps, it's sometimes been stated as an operational framework that uses Git as the single source of truth for managing and automating infrastructure and applications. There's a little bit more to that. Fundamentally, GitOps is a framework, right? It's got a set of 4 key principles that are about helping to make deployments to environments like Kubernetes simpler and more predictable. So the first principle here is about being declarative, right? Essentially, what you want to do is define the state that you want your system to be in, and that's basically your input into the process. All right, so you've probably seen Kubernetes manifests or Argo applications or even Terraform files. That's kind of that declarative state, right? It's defined not imperatively. It doesn't define what the process should be, It just defines what the state should be. So this, coupled with the versioned and immutable principle, is why it's often assumed that Git must be a key part of GitOps. And it's kind of in the name, right? Why? Of course, it must be Git. The reality is, though, there's other storage mechanisms that fit the bill. And as we'll see when we talk about Argo, there's others that are often used. Pulled automatically, the third principle, that's a little bit of an odd one out. I think it speaks a little bit too much about the how rather than the what. The reality is that for some scenarios, pushback-based mechanism sometimes is optimal. So I'll be a little bit controversial here. I think the pulled principle shouldn't be taken as such a strong requirement as the other three. The last one, though, is continuous reconciliation, right? And this is one that for a long time, I myself wasn't really sure how it fit in, how important was it, what did it drive, what was it trying to solve? But I've since come to realize that this is probably one of the most powerful parts, one of the most powerful principles of GitOps, I think. Continuous reconciliation describes this idea that you should have your desired state and you should have some tool, some GitOps tool, which is continually comparing that state with the rest of the world and ensure that it's always kept in sync. Right, and this is pretty powerful. What that means is we can look at some declarative configuration and provide some statement about our understanding of it being an accurate picture of the world. What that means, essentially in practice, is you'll have that desired state stored in Git or wherever else it is. You'll have that GitOps process that's sitting there watching that desired state. And it's also watching the current state of that system in the world. When there's drift between them, that GitOps tool will adjust the current state of the world. So it might be doing applying some manifest to Kubernetes, ensures that brought up state, and then keeps watching it. So it kind of happens in this, what's called a reconciliation loop. So what's it all trying to solve? Well, it's no coincidence that GitOps and Kubernetes are typically spoken together more than any other platform or tech stack, right? Kubernetes combines both your infrastructure configuration state and your application state in a single set of manifests. And it's from this particular medium that GitOps is formed, right? When you define your configuration in that manner, it becomes a lot simpler to define it declaratively, right? It makes your intentions very clear and unambiguous about what you want the entire state of the system to be. With continuous reconciliation, we can then have that confidence that we know that that system is in that state and remains in that state. So we can see how GitOps is something that governs state. It's not really describing the delivery flow. It's not the release process itself. It's just a step in that applies those changes you want, performs that deployment. And additionally, this is the big light bulb, I guess, of GitOps. It ensures that after that deployment takes place, it's also kept in sync. And that's something that you don't often see in sort of more conventional processes. So we've talked about Argo CD. Kit's mentioned Argo CD a few times. How does it fit into the picture? Fundamentally, Argo CD is just one tool of many that supports these GitOps style deployments specifically for Kubernetes. So as mentioned, Kubernetes, it's the original and most common subject for GitOps practices due to the declarative nature. You could conceivably apply it to other scenarios, but we'll focus here on Argo and Kubernetes specifically because it's most common. So Argo CD, it will utilize a Git repository as a state store, but it also can use an OCI registry for its declarative state. So notice I said there, it could be one or the other. Just very briefly on what OCI is, it's Open Container Initiative. It defines a set of standards for defining sort of how containers are distributed and stored. But now more and more it's being used for distributing other artifacts like SBOMs or Helm charts. You've probably seen used quite a bit. The key thing to keep in mind is it's not just Git. Git is not the only input into this GitOps process. GitOps, funnily enough, as we went through those principles before, you notice none of them actually talked about Git specifically. So how does Argo CD itself work? Well, as we can kind of see in this diagram, when you make a commit to, in this case, a Git repository, Argo CD there will be sitting there watching that repository, pulls those commits, and then it performs that reconciliation loop with Kubernetes. It'll apply and sync those resources and checks those the state of Kubernetes and kind of performs that in that loop. notice when we talked about Argo CD here, when I went through that process, none of it really talked about that broader part of the delivery pipeline. None of this process here in this diagram or what we've described in GitOps talks about what we should be doing with our testing, what we should be thinking about when we talk about environment promotion. Argo CD and GitOps really is fundamentally focusing on doing one thing, right? It looks at the configuration that you've defined as being the desired state, and ensuring that the real world matches that. So you can think about its place in your deployment pipeline as being kind of just a slightly more persistent version of a deployment process. It just kind of plays one part in that whole broader thing. In that continuous delivery pipeline, or in that release process within that, maybe you want to do database upgrades, or maybe you need to run infrastructure provisioning only for one environment or not the other. None of this process really talks to that. Not only that, but you want that process to be repeatable for every single environment with different configurations for environments. Maybe you've got multiple environments, or maybe you've got multiple tenants, or maybe you've got multiple regions that you're deploying the changes to. Argo CD is one part of that process that helps you achieve that, but it itself is not continuous delivery. It's not trying to be, and nor should it. Continuous delivery is an imperative process inherently, right? The steps in the process might be defined declaratively, but running that process is inherently imperative. So hopefully from that background discussion, we can see how GitOps on its own doesn't provide continuous delivery. It's not opposed to continuous delivery, and the inverse is not true either. It's a useful part of that continuous delivery process. Argo CD handles how the deployments happens, not the entirety of that CD workflow. Just like the act of performing the deployment has never been the entirety of CD, the same still holds true in the world of Kubernetes. Again, I'll be a little bit controversial and say that essentially Argo CD and GitOps is just really the newer version of what we used to do when we FTP files to your web server. All it's doing is taking that change and applying it to the world. What is new though, and what is powerful, is the fact that you can not only look at that expected state outside of your deployment, but you can have this confidence that it will continue to apply after the deployment takes place, because it's active outside of the deployment. So Argo CD and GitOps gives you this powerful operational model for how you apply those changes, but it doesn't design your pipeline, it doesn't validate quality, it's not creating those safety gates, it's not ensuring you've got those small batch sizes of changes or really guaranteeing that reliable process. CD still matters, and GitOps is just one part that helps implement that. So I've talked a little bit about the background there of what those concepts are. I'll leave it to you to talk through what some of the problems are that people face, or they kind of get confused with as they go through the implementation.
Thanks, Rob. Thanks for the great overview. So we talked about GitOps, continuous delivery, Argo CD, and yep, probably Argo CD and GitOps is not the same as continuous delivery after all. But the question we had back in a year ago, the end of 2024, is, okay, we maybe know that, maybe it's true conceptually wise, but is there a problem for people who actually use GitOps? Basically, does anyone actually care about that, right? How can we prove this? So we looked into some data we collected through our research interviews, but actually also later, earlier this year, a survey came out. So Argo CD community asked their users about the main challenges they face, basically unresolved needs, unmet expectations. And among other things, one particular need became like top one. I think it was like as popular as like 2 out of 3 people voted for it. And this need is support for promotion apps through stages. It doesn't really say delivery automation, it doesn't really say continuous delivery, but it's very clear of what people actually want here. So let's talk about this a bit more. So what do they actually want from this? What do they mean when they say promotion apps? The same survey gives us a bit more details into what challenges people associate with the promotion challenges. If you read the full article on Medium, you'll find way more details. But in a nutshell, when people talk about these challenges, they often mean traceability across environments. I want to know what was deployed when and where. They talk about understanding the app health and status, but not just for this particular app, but for all apps across environments again. So this is like a pattern. People really care about things in the context, not in isolation. Another issue is keeping pipeline definitions consistent. Again, this is about like I want to know that the thing will happen in the same order again and again and again. And to more troubleshoot failed promotions, therefore failed deployments in a way, and release gates. So what does it tell us? It tells us that then people think about promotions and name promotions as a challenge. They don't really mean deployments. They mean the full software delivery automation. They mean deployments, they mean orchestration, they mean testing, approval, specification, all that. And we think about what describes all those problems, what we use to automate all that. We actually talk about continuous delivery. So let's say we establish a demand is there. Okay, continuous delivery or software automation or software lifecycle automation is a challenge for GitOps and Kubernetes. But hasn't it yet been solved? This was our second question on the list. So, okay, if the problem is there, community is great, it's amazing. There are so many people building stuff, new tools come every quarter. So definitely there should be something there, should be a solution available. Is it available though? Before we go into that, we talked about what does it actually mean to have a good solution. Solution should have certain criteria, right? If we want to build our own solution, how we will know what we should focus on? So we worked up this list of like priorities. So first, we thought about a good solution for this problem should offer full automation. Someone cares, but not so many people will care if you can automate just 15% of your cycle, but then you still have to do everything else manually, or with your custom scripting. So the more you can cover, the better. That was like the one main criteria for us. The second, as important as the first one, is we actually talking about people who ship software, not people who run Kubernetes, not people who manage automation, people who ship software. So for them, the whole deployment cycle, software delivery cycle, it's just a second priority. We should focus on their experience. So they should not be distracted from the main function they work on. We should look at this through their eyes, not through the eyes of infrastructure people or platform engineers. The third, also important for developers, is speed. No one wants to sit there for 4 hours waiting for the change to get tested and went through the pipeline to the production and just then learn that something was broken. So we want those feedback loops to close within like 15 minutes, 20 minutes max. Our solution should be reliable. So think about a good solution. It should allow us to achieve the same result again and again. No one wants to debug every third deployment. And our solution should work at scale. If it works for one team, it's good, but it should work for 5, 10, 15, and in some cases, hundreds of teams. Otherwise, it's just unusable. You can't really apply it to a real org. And finally, no one wants to hire 2 teams of engineers just to constantly manage and develop your in-house CI/CD GitOps solution, right? You need something that is easy to manage and just affordable. Doesn't necessarily mean you pay money for this, but at least like the cost of ownership is low. So having those criteria in mind, let's look at what people currently use. Do they actually have a solution like that? So in the same Argo CD survey, users were asked about the tools they currently use to automate promotions through environments. It wasn't a surprise for us because we did research before, but just looking at the numbers again was kind of revelation. So most people, and this is like I'm talking about absolute majority, still use either in-house scripts that run on CI tools, and we mean here Jenkins being the most popular one, and then GitHub Actions, the close second, and GitLab. So it's still like ad hoc custom in-house automation. Some people build quite sophisticated in-house CD solutions like standalone tools. These might be like hard to manage, but still they exist. And half of the audience, think about it, still do manual promotion. So despite all those problems mentioned before, despite the challenges, people don't have a good tool to solve those challenges. They still do like bespoke manual solutions. So our conclusion end of last year was, okay, orgs really have the problem. They have to solve this problem themselves. And because they're unhappy, it's obvious that those answers just don't work for them. So then the third question we had is, okay, with all this picture, why don't the current solutions that are already there, like dedicated solutions, why don't they cut it? Why people, if you look back here, why all those solutions combined give us less than 10% of the market share? What's going on there? So here I should give it like disclaimer, and it's true, and it's the honest thing to say about our current state of the whole ecosystem. Most of those tools are very, very, very early. They're still going through like the first couple of cycles of development. They will definitely get more attention and they will get more users. That's no doubts, and we'll see that with the next few years. But also when we analyze that, I think we spotted one thing, and this is our like personal opinion here, but I think a lot of those tools, they look at the promotion issue, or continuous delivery issue, or software delivery automation cycle issue through the GitOps lens. So they start from GitOps and they just try to add things here and there to make the scope a bit broader. Let's say I have my deployment, which is configuration update, and I want to add things like a step before and after, like a couple of checks here and there. Or I want to create a sequence of environments to describe how those promotions should, exist one after the other. That's great, but it's not even close to the actual scope of CD, right? When we talk about CD, we talk about I need to orchestrate things. I need to have dependency management. I need to have approvals. I need to update my configuration management. I need to run some testing, and I need to have security validation. So all that is also part of this process. And then we look at how people use those tools. It looks like you still have to do a lot of these things yourself. So basically, you use one of those tools, and you still need to do a lot of extra custom scripting or development yourself. I think this might be one of the reasons why it's not necessarily working for many customers, and people still lean towards like manual deployments or CI tools. So
just one that data you've got.
Yeah, go ahead.
What I love about that data, if you go back to that diagram a slide or two ago, is it really sort of points out how sometimes you get this warped view of the world when you go to conferences and you hear people talking about this tool is what everyone's using and this is what you should be doing. The reality is that's not necessarily the case that's actually out there. So, if your process is still not, fully automated end to end, or you're not using the latest and greatest tool, that's fine. You're not in a minority. The key thing is just think about, okay, what next steps can I do to make things better?
Yeah, and that's exactly what we did. Actually, we were sitting there, end of 2024, and we were just thinking like, can we do anything better? And we like got to the whiteboards, spent a bunch of time doing like a round of ideations and more user research and surveys and then prototyping and go back to the drawing board again. And as a result of all that, we actually came up with 4 principles. Again, we built our solution using those principles, but I think anyone else can do the same. So maybe if you build your own in-house tool, not necessarily using Octopus, it would be useful for you too. We found it useful, and we run a bunch of UX testing and realized, yeah, probably it resonates with people. I just want to share those 4 principles with you. So first thing where we started is we really believe in the integrated deployment process. So we're thinking about GitOps as a keystone, as a part of the big thing, the big picture. So we start with CD. We think that we need to model GitOps deployments as a part of the complex process and allow people to do everything else, like model their environments, model applications, model clusters, model the promotion process, and bring manifest update into that versus trying to add to GitOps, like from the inside. So think broad and go narrow, not the other way around. The second principle we used is, and this is maybe one of the most important ones, we really learned that people want, for good developer experience, you want to combine CD and GitOps visibility. Visibility is extremely important. You want to know what's going on in your cluster, you want to know what's going on in your deployments. Unfortunately, in many solutions, you have only one or the other, and you need to, mentally cross-check a couple of tools to get the full picture. So as soon as you bring it all in one place and you can answer the question, what happened, when happened, is it healthy now, and look at all the logs, both deployment and app side, that makes life way easier. So I think this is essential for a good tool here. Another one is avoid duplication. You don't want to configure things twice. Again, with many solutions we see, you need to configure Argo CD apps, you need to define what app is doing, where it runs, and then need to refer the same app again if you want to include it into the CD process. And then you change something on Argo side, you should keep in mind that now you should change something on the CD side. You're doubling the configuration, make it laborious, leads to errors. Essentially, people give up on those solutions. So don't do it. Keep one thing, keep one social truth. And finally, you should follow GitOps principles. All of that makes no sense if you try to automate CD, but forget where you started, and you start with GitOps. So more than often, we see that people doing automation around Argo CD and in general try to do something like, oh, I will not update the manifest, instead I update just the application configuration, or let's switch off the auto sync and just trigger sync manually, or like, through a tool, or do many other things. What you end up doing is you just trading off GitOps towards automation, forgetting why you started in the first place. So don't do that. We think that both concepts should coexist. And yeah, finally, with all 4 principles again, look through developer eyes. Don't think as infrastructure engineer or as platform engineer. Think as a person who just merged the last commit into main and want to get feedback from the tool 15 minutes later to know if it was deployed successfully, and if there are any issues, have an easy path to resolve that. All right, so if you want to learn more about our process, not just solution, but how we went there, etc., we have a bunch of resources available. We have a big webinar, we have a blog post, docs, and we have samples. I actually would really recommend the samples because you can really see how those things could coexist and work together there. And yeah, finally, like just to summarize within 1 minute, we started with asking ourselves, should you choose GitOps or should you choose continuous delivery? Is there a problem like that? And I think the answer here is, the honest answer is, you don't need to choose. So you just want to use the right tool for the right job. If you're an infrastructure team or you manage configurations and you do the ops task, use GitOps. If you want to automate software delivery, use CD. If you want to automate software delivery for the platform with complex configuration management like Kubernetes, just use both. Don't trade off. Find a way to implement both and benefit from it. Yeah, and that's it. Thank you.
Awesome stuff. Thank you very much. Great to see a lot of the insights there in the slides that you guys have shared. Just remember that everything is being recorded. I know that we're producing a lot of links, etc., for people to keep track of. Everything's recorded, going to be available up on our YouTube channel a little bit later on. Robert, thank you very much. Kit, thank you very much. I know you did back-to-back sessions there. Awesome stuff. All right, let's go ahead and bring up our schedule once again. Our schedule, obviously, is we are in the home stretch now. We've got actually a couple of great speakers coming up next. We've got Steve and we've got Nathan, who I'm going to invite to the stage. They're going to be doing a session entitled Dora, Beyond the Metrics. And this is a session that's going to feature 2 people who have spent a lot of time, obviously, focused on Dora. And so let's go ahead and invite them to the stage now. Hi, how's it going?
Hey there, how's it going, John? Hey, Steve.
Hi.
Hey, how's it going?
Joining us, really appreciate it.
Oh, really excited to be here today.
Awesome. Do you guys have slides that you'd like to share, or do you guys just want to have a discussion, or is that the intent?
Yeah, we do have some slides that I'm pulling up right now.
Okay, no worries. This is the equivalent of us tap dancing on stage. There we go.
No,
it's now.
All right. Well, hey, John, thanks so much. It's really exciting to be here. And hi, everyone. My name is Nathan Harvey. I lead up the Dora program here with Google Cloud. And this is my first shipped. It's, of course, not the first time I've shipped anything, but it is my first shipped conference. And I'm so excited to be here together with Steve. Hey, Steve.
Hey, how's it going? Hi, everyone. I'm Steve. I am a Dora community guide, and I have the t-shirt to prove it. And I also work at Octopus doing some of the research here too. And we are super fans of the Dora research because it's been over a decade of really high quality insights, and I've been following it the whole time in awe.
Yeah, it is hard to believe, but yes, it has been over a decade. And yet, Steve, sometimes there are people that haven't heard of Dora or have maybe heard of a different Dora. So let's just level set and let everyone know that today the Dora we're talking about is a research program that, as you mentioned, has been running for over a decade now. It's been about 12 or 13 years. We've kind of lost count. But this research is looking into the capabilities that drive and enable technology-driven teams and organizations to actually thrive. Our tagline is "Get better at getting better." We really want to help you and your team go on a journey and have a mindset of continuous improvement. That's really what Dora is all about. And the title of our talk today is Dora, Beyond the Metrics, right? We want to look beyond the metrics. But again, just to make sure that we have level set everyone, maybe we should start off with just what are we talking about when we say the Dora metrics? Well, the reality is that this research program is pretty deep and intensive and looks across a lot of different things. But one of the things that it's most known for, or most well known for, is our measures of software delivery performance. In fact, Dora for a long time has had 4 measures of software delivery performance. These measures help organizations and teams look at 2 high-level characteristics of software delivery. The first is throughput. How much change are you able to move through the system? And then the second is stability. When that change makes it into production, does it land in a stable way? Now, the original 4, sort of the old school metrics, are these. You have your lead time for changes, which really answers the question of how long does it take for a change to go from committed to version control. And I know the talk just before us was GitOps, so you're probably taking those code changes and putting them into Git. How long does it take for those to go from locally committed all the way through to running in production? And how frequently are you updating production? Those were the 2 throughput metrics. And then on the stability side, you have the change fail rate, which, Steve, I call this the O expletive rate, because this is the rate at which you push something to production and you or someone around you shouts out an expletive. Has that ever happened to you, Steve?
Of course not. It's never happened to me, and especially not at super inconvenient times.
Yeah, definitely not. And then finally, our 4th metric here in the classic Dora metrics is the time to restore service. So when there is an incident or an outage, some interruption to service to our customers, how long does it generally take you to recover from that? Now, taken together, these 4 metrics have a lot of power. First, they can be used to measure any application or service that you're looking at, whether it's a mobile application or a mainframe application or a really rich SaaS offering, or even your internal platform that you're offering to developers within your organization. So I think that's a really important point about these. But then the other thing that's really interesting here, if you go back through the entire history of this research program, there are certainly those in the industry, and maybe it's a smaller number today than it was when this research began, but there are certainly those who think of throughput and stability as trade-offs of one another. We can either be fast or we can have stable deployments, and you kind of get to pick between the 2. But the reality is, with our research, what we've seen, again, over more than a decade, is that throughput and stability tend to move together. You're either fast and stable, or you're slow and unstable. So I sometimes like to quote Dave Farley here. He says that the choice is really, over a long enough time horizon, the choice is really, do you want better software faster, or do you want worse software slower? You get to pick. Steve, how does that, what's your experience with this idea of throughput and stability being trade-offs of one another?
So I think that they are trade-offs when you set up 2 teams with the opposite goals. So if you have a team who are in charge of throughput and a team who are in charge of stability, that's when you will find there's conflict and it doesn't work out. And mostly it's because they end up creating lots of trip hazards for each other. So I think one of the reasons that intuitive thought these things must be in conflict doesn't turn out to be true is because in DevOps, we don't set up those teams to be in conflict. We try and give them the same shared goals. And it's almost that might be the little simple start of a really big change.
Indeed, and that definition or that description definitely resonates with me. You know, I spent an early part of my career sort of on that operations side. I was responsible for the production systems, and you know, having conversations with leadership around, hey, Nathan, you've got to make these systems more stable. I know the way to make the systems more stable. Accept no changes. Sorry, you want to change something? Go away. Can't do that. Of course, that doesn't help my development peers who were trying to ship new features, and they were getting similar pressure, although maybe from a different angle, from their leadership. And at the end of the day, if we ship nothing, that doesn't really help our customers. And if we ship very infrequently, that's not helping them either. And that stability really matters. So I think this is I think part of why these metrics have really resonated with the industry. But speaking of these metrics, I've said a couple of times that these are the original 4 metrics. You know, our research is kind of like, well, it's kind of like your team. We don't sit still. Things are always evolving. And so over time, these metrics have evolved. We've moved the first change was that we changed from your time to restore service. We've kind of clarified the definition of that and talked about the failed deployment recovery time. And one of the reasons that we switched that is it can be really sort of difficult to take any sort of incident or interruption you have and sort of average those all together to figure out how long did it take you to recover from them. The reality is that, let's say, for example, you're deploying software in a physical data center. If a backhoe comes and cuts power to that data center, certainly happened, how long is it going to take you to recover from that? Well, the answer to that question is very different than if you ship a bad configuration, how long is it going to take you to recover from that? I hope the answers are very different, but averaging them out doesn't really give us the information that we want. We can't really learn so much from that. There are a bunch of other reasons as well, but probably the most important was that these 4 measures were always about software delivery performance. And so we really wanted to zero in or hone in, if you will, on those failed deployment recovery times. So that was kind of the first change that the metrics took. But then in the last couple of years, we've actually made one more change to them. And in fact, our 4 metrics, they've grown up. They're now 5. There are now 5 software delivery performance metrics. You'll see 4 of them look exactly the same. The 5th one, though, is the rework rate. And this is really, I think, will probably clarify some of the language around this. This is specifically the deployment rework rate. So, you know, when you have one of those expletive moments where you have to roll something back, you're probably going to eventually ship more software. So you're going to do a deployment that is a reworked deployment, a deployment that wasn't planned. And so we really want to understand the characteristics of that deployment and how many of those relative to all of the deployments that you have come across there. So this is kind of how the 5 metrics have evolved. And Steve, I know you wrote a post just recently about these 5 metrics. Can you share a little bit of insights that you had and takeaways that you had from these?
Yeah, I think there's 2 interesting things I'd call out on this. One is that this rework rate gave me flashbacks to John Seddon's concept of failure demand, right? It's like if you imagine something simple like your job is to fold paper, and you say, I've folded 100 pieces of paper today. But if half of those pieces of paper were ones that were sent back because you folded them wrong, you haven't really delivered 100 pieces of folded paper, right? You've only delivered 50.
Right.
So that's what we're kind of talking about here, is that maybe you've got quite a good looking deployment frequency, but if half of your deployments are to deal with these kind of failures, that's an interesting number, and that's something to kind of look at. The other thing that I think is really interesting, and I think you could probably give us some insight into this, is that the throughput and stability has changed here, right? Because one of our metrics has popped across from the stability camp into the throughput camp.
Yeah, that is really interesting. So the failed deployment recovery time, good eye there, Steve. That has moved from a stability metric to a throughput metric. And I will share some of the rationale behind that. You know, when you have a deployment that goes off, it fails, something's gone wrong about it, and you need to immediately intervene. You kind of have, I would say, at least at a high level, kind of 2 choices. You can either roll back that change, or you can push forward some new software. And even if you roll that change back, you're probably going to end up pushing forward some new software. So this failed deployment recovery rate then, or recovery time, sorry, is really a measure of software delivery performance, because to fix that failed deployment, you're shipping more software. Now, the interesting thing about this, and the way that I kind of like to think about these, is your lead time for changes. That's kind of your normal lead time for changes. You know, I've got a new change, I need to ship it off. Let's get that out into the hands of our customers. But when it goes wrong, now we have kind of an incident or an emergency. Maybe we have an emergency fix that we need to deploy. That would be the failed deployment recovery time. It's a measure of throughput, right? We're still pushing software through. But when you can compare and contrast your lead time for changes and your failed deployment recovery time, you'll probably find, hopefully, that your failed deployment recovery time is either equal to your lead time for changes or maybe even a little bit faster. And so at a conceptual level, you're kind of measuring the normal changes and those emergency changes. That's the difference between the two.
Yeah, I love that. And one of the interesting thought exercises around this is if you're able to ship a fix quite quickly, the idea should be, how can we just ship all of our changes in a similar way, right? So it's kind of, that's one of the thoughts behind continuous delivery. Like, we've proven that we can do this really quickly when we need to. So why does it take us like 2 months when it's not an emergency?
Yeah, and one of the key insights that most teams end up having around that exact question is, well, when it's an emergency, we're just shipping a little bit. We're not shipping a lot. We're just shipping a small bit at a time. Yes, mind blown, right? That right there is the key insight. If we ship in smaller increments, it is very easy for us to increase both the throughput and stability of those changes. And in fact, if we're shipping something small and something goes wrong, first, it's easier to repair or to roll back. But second, because it's small, maybe we've actually contained the blast radius of that incident, and it's not impacting all of our users necessarily. So when you start thinking about just ways that you might improve both throughput and stability, you start finding lots of little things that you can do, like shipping in smaller batches, like focusing on how deployments get released out to your customers. Maybe you're doing something like progressive deploy, where you start by releasing to a small number of users, maybe catch an issue there before it hits all of your users, and things along those lines. Yeah, so that's super cool, and those are the software delivery performance metrics. But we said we wanted to look beyond the software delivery metrics. So let's go over to Dora.dev. Now, Dora.dev is where the research program publishes all of our findings, has information and insights into the metrics and so forth. And I really like to start right here on the research page itself, because the first thing that we come across on the research page is this Dora core model. This model represents sort of all of the findings that we've had over the decade plus. We kind of consolidate them down into one model to help you better navigate how things work. And you'll see right here in the center are those software delivery performance metrics. But as this is more than or beyond those 4 metrics, you'll see immediately that there's also reliability metrics, things like operational performance. We do consider that separate from software delivery performance, but they certainly are related and inform one another.
And it's kind of crucial here because I think a lot of people have heard of the 4 keys, the 5 keys as they are now.
Yes.
But even in terms of measurements, there are more ideas to be found in this model about things that you might want to measure. And reliability is a great one. There's also these cool things over here, like job satisfaction, productivity, and
Yes.
reduced burnout. You know, these sound like good things to have in an organization too.
Well, burnout maybe not so much, but yes, the reduction in burnout, absolutely a good thing. And this is another key point about these metrics. I like to say that these metrics sort of form the center of gravity, if you will, for Dora. What our research has shown is over the years, these metrics are predictive or are leading indicators for those outcomes that you care about on the right. Things like organizational performance and well-being. but they are also trailing indicators for the capabilities and conditions that you see on the left, a climate for learning, fast flow, and fast feedback. The reality is that you don't improve software delivery performance by thinking really hard about your deployment frequency or by mashing the deploy button. Well, I mean, I guess if you mash the deploy button over and over again, that will improve your software delivery performance, but not in a meaningful to the business way, right? And so this is really interesting. Those performance metrics, those software delivery performance metrics in particular, they help us predict what the outcomes are going to be, and they provide a trailing measure for how are our capabilities and conditions, what's our engineering excellence, if you will, look like in our engineering practices. Now, we can go much deeper than just those top level categories. In fact, I'm just going to expand it out here. Ooh, that was fun. Did you see that navigation or that animation there, Steve? Watch this. Ooh.
I love that.
Isn't that fun? Yeah. I mean, I could just do that all day, but of course we wouldn't be improving much if we just watched the web animations happening. But so what stands out to you here, Steve?
So for me, this is really the crucial thing. The metrics are the useful signal and the thing that we can use to inspire us to find ways of improving. But for me, the real like calories in this model are the things in this dark blue box on the left-hand side, which are these concrete things that we can do. They're called capabilities, which sounds really cool, but it's stuff we can do that will help us to deliver software better. So these are the levers we're going to pull to solve the problems that we have and that are making us work in larger batches and have problems.
Yeah, I love that sort of metaphor as these are levers that we can pull. And frankly, some of them as a team or as an individual, you might have access to, and others you might not. I tend to think about these capabilities also in the idea of levers and knobs and dials and so forth as kind of like you're sitting in a cockpit. And maybe it's a cockpit for a very large airplane. And so there's a pilot and there's a co-pilot, maybe there's even a navigator. Well, if there's a navigator, the navigator has access to some knobs and dials that the pilot cannot reach just because of where they physically sit. And I think that's true about these capabilities as well. I mean, one of the capabilities that you'll see here is a generative culture. And this is a culture where information is shared, where risks are encouraged, where when something fails, we try to learn from that. Now, you can't just walk into a new job or walk onto a new team and expect that, well, within the next quarter, I'm going to significantly change the culture of this entire organization. You can't reach that lever. I mean, you can start to influence it, but you're not going to be able to fully reach that lever, if you will. But then we have other things like version control. Maybe as an individual contributor, you can start making sure that every artifact that we have is stored in version control. So some of these levers you have access to, and some of them maybe are a little bit more distal. And that also might talk about the time horizon over which you can change them.
That's right. And I think one of the things to bear in mind is that some of the small things that you do control will actually help you to bring about the things that are maybe even outside of your influence. So the example I often use is I've been on teams where we've done such a bad deployment that nobody trusted us. So we needed to do things like add monitoring and observability and do deployment automation to show that we were actually trustworthy, which then allowed people to give us more autonomy to make other changes that maybe were outside of our control, such as, reducing the overhead of change approvals.
Oh, yeah, absolutely. And I love that idea that, we can make a small local change and that's going to have a ripple impact or a ripple effect and drive the larger changes that we need to have. And that whole idea of trust, I can't tell you how many times I've lived that especially when it comes to deployments. When we had in a previous role, when we had a lot of failed deployments and we went to the business and we said, the best way to fix this is to ship more frequently. As you can imagine, they weren't super excited about hearing us say that we were going to break things more frequently, which of course wasn't what we were saying, but it is what they heard because that was their lived experience. Now, the other thing that I really like about how you approach this is, with those capabilities on the left-hand side, that it kind of gives you an idea of these are the practices, the conditions, the capabilities that we need to have on our team in order to drive better software delivery performance. So that's really good, but there's already a lot of capabilities there. So where do I get started, Steve?
Well, I think probably by trying to work out the current state that you're in.
Yes, I think that's a really great idea. And I've done this a couple of different ways. I'll describe one and then we'll walk through one of them. One way that I've done this with teams is, frankly, we take this model and we print it out on a giant poster-sized board, and I give teams red and green stickies and maybe some yellow stickies. And maybe you get 2 or 3 of each. And I say, okay, look at this list. Go put the red stickies on the things that you experience that are bad or have lots of opportunity for improvement. Put the green on the ones that you think are good, and the yellow on those that are maybe in the middle or you're curious about. And it is fascinating to watch as a team comes together and starts doing that on this map or on this model, how clusters start to emerge. We think we're really good at version control. We think we have lots of opportunities around documentation quality. So that's really one way that I find is super successful to help teams, because then it also helps them understand that, well, we're pretty weak in documentation quality, but we're pretty good in version control. Let's make sure we're the best at version control. What happens when you do that, Steve?
Well, I think one thing I'd quickly add there is that having the team in the same room doing this, or like all together doing this, and making sure it is that whole team. The cool thing about that is someone will be new to your team and they will see the gaps in your documentation which you don't see. It happens every time. Whenever someone new comes in, you're like, our documentation is great, you'll have no problems. And it's just immediately they'll say, where's the version control? Like, where do I go to find my repository? And it just won't even be in there because it's so obvious to you. But yeah, once you can actually map out and highlight these hotspots, for me, it's like being curious about finding out how to actually implement this new skill that you have to try and acquire.
Yeah, I love that. And that leads me right to a way that I want to show you that you can actually kind of do that together with your team right from the Dora.dev website. So I'm just going to pop over here to the quick check. And the quick check starts off by helping you sort of assess how is your software delivery performance going. And what you'll see here is that well, our deployment frequency could probably improve. We are still only showing you or measuring 4 of the 5 metrics here in the quick check, but stay tuned. It's a website. Things are always changing. So I've not really considered the answers. I've just thrown in a bunch of different ones. What this does immediately is it helps me get a baseline for my team and understand how is my software delivery performance going today. Now, one of the things that I did that was terrible just now is I just answered those questions myself. To your point, Steve, it's really much better if we can bring together sort of a cross-functional representation of the team that is required to build and deploy and operate this application and talk through those answers, because we all may have slightly different lived experiences with each one of those. But then, now we know how we're doing, we want to start prioritizing some of those capabilities or even assessing some of those capabilities. The quick check actually helps you with a couple of them. And I think this is really important because one of the things that we can't do is just say, are you practicing continuous integration? Yes or no, or like on a scale of 1 to 10, how are you doing with continuous integration? The challenge with doing that is how I think about continuous integration might be different to how you think about continuous integration. So what we do here in the quick check is we actually give you some characteristics, some pointers or some signals around how good are you at continuous integration. For example, Steve, where you work, do code commits result in an automated build of the software? How
Yes, they
strongly do you agree or disagree with that?
Yeah, they definitely do. We have
They definitely do.
builds.
Awesome. Awesome. All right. I'm going to ignore your answer, and second, we're not going to go through all of the other questions because we simply don't have time to. But you can imagine, maybe my experience is different to yours, Steve, and so just talking through that, we can already start to get some good understanding of maybe opportunities for us to improve. We can do the same thing here with loosely coupled teams, and then finally with your generative organizational cultures, information actively sought. Again, I'm just going to throw in a bunch of random answers here. New ideas are welcomed. I strongly agree with that. And now we can view the results. And so what this does is it shows us sort of that stack rank of which capabilities are we really strong in and where do we have the most opportunity to improve. So Steve, what would you like to do next here?
Well, I think we need to find out a bit more about continuous integration so that we can work out how to strengthen our score here.
I dig that. Let's do that. And so right here on Dora.dev, again, we've got guidance on every one of those capabilities. And the articles around those capabilities follow a pretty similar pattern. First, what is that thing? In this case, continuous integration. How do you go about implementing it? Some of my favorite parts here are the objections and the common pitfalls that you might run into. Because, we're talking about changing things. Change is hard. Change is hard. It's hard for a lot of reasons, and sometimes people are resistant to change. They're well into their workflows and very happy with them and so forth. So it's always good to think about those. But then we also have, sort of rounding out the article, ways to measure each one of those capabilities. So again, there's certainly more than 4 measures within Dora. There are hundreds of metrics, hundreds of measures that we look at. So this gives us a way to get a good assessment of how we're doing with continuous integration today. And then, of course, some what's next, because there is no such thing as a good article without something that tells you what's coming next. But in any case, now that we've got an idea, we could actually, I don't know, maybe set some OKRs around these factors. But more importantly, what we can do is we can sit down and we can write a hypothesis, Steve. We can say that our goal is to improve our software delivery performance metrics. We believe that by improving continuous integration, we're going to see an improvement in those software delivery metrics. And as those software delivery metrics improve, we also expect to see better organizational performance, whether that's commercial performance or non-commercial performance, like customer satisfaction or something like that. And we expect to see better well-being for the people on our team. So we've just set up a nice hypothesis that we can now go and test as a team. Talk about a great way to learn and experiment as you go.
And with this hypothesis, right, we test it for a week and then we realize it's not working, so we give up, right? Or is there a J curve here?
Yeah, so the J curve is really, really interesting. I'm glad you brought that up. First, something like continuous integration might take you a little bit more than a week to get well practiced in and sort of build the habits of practicing continuous integration. There might be technical challenges, and there certainly might be process and people challenges or changes that need to go into that. But with all change, we have seen over and over again in our research what you just called out there, the J curve of change, where maybe there's a little bit of low-hanging fruit, and we pick all of that really good, and we're really excited about how this change is going. But as soon as you've picked all of that low-hanging fruit, the change gets hard. It gets difficult. Maybe you're having problems scaling that change beyond one team or across your organization. Maybe you've run into some technical roadblocks with it. Who knows what? But that's where your productivity might actually take a dip. We have to recognize that that's likely to happen. And we've seen that happen again and again with a number of things across the research. But what happens on the other side of that is the J bottoms out and we come back up and we eventually get to a place where we do have better performance. So it is really about building that practice of experimentation and learning. And you have to stick with it so that you can really recognize and realize the gains from those new capabilities that you're building.
That makes total sense. It's like having a savings account and putting money in it, and then in the next week saying, well, the number hasn't gone up.
Yeah.
It's like I'm not getting any interest. It's like, well, the interest comes over time and it kind of compounds and gets bigger and bigger. So you kind of have to invest for a bit of time. It's not decades. It's shorter than that, but it's definitely longer than a week.
Absolutely. And you might start to see some changes within the week, but it is This is why we have that tagline of get better at getting better. It's a process of continuous improvement, and it's those iterations and that iterative approach where you're learning as you go and building those new habits. One of the challenges, though, I find with that is because you are making relatively small steps forward all the time, we tend to stop and look back at just how far we've come. You get 6 months, a year into this journey, and it feels like you've only taken a few small steps. But if you stop and reflect and really look back on some of the changes that you've implemented over that year, I think you'll be blown away.
Yeah. And that's one of the reasons why it can be useful to measure, because that way you can then see that difference, in a way that we often forget, like the pain of the past. That's why I've got so many tattoos. But, if you actually can look back at a chart and see the difference, it can remind you of how big a improvement you've made.
Yeah, absolutely. Absolutely. Now, Steve, earlier you mentioned that you were an Octonaut, yes, but something else that you said there at the beginning when you introduced yourself. What was that?
About being a Dora community guide?
Yes, the Dora Community Guide. What exactly is a Dora Community Guide?
So that's a very good question. The Dora community is a group of people who are all interested in this subject. It's the topic of how we measure software delivery, but also the things we do to actually make a difference to how well we deliver software. And there's a whole community of really cool people. And every time I turn up to one of these, I learn loads. As a Dora community guide, I'm here to help kind of grease the wheels on it and get conversations going and kind of like cheerlead the research when it comes out. It's one of my favorite jobs. So look out for me doing that. So yeah, come and join the community because we have conversations on a regular basis and they get super deep and super interesting. I always say like we kind of go there and we talk about things like these metrics because we're the cool kids. And anyone who agrees that we're the cool kids, this is definitely the place to be.
Yeah, absolutely. And you can get to that community right here from the community link on Dora.dev, which takes you to Dora.community. And from there, you can join the community of practice. That's a mailing list. We get together regularly and have online discussions where, as Steve mentioned, we're talking about what we're learning with taking these findings from Dora and putting them into practice. Now, Steve, you also mentioned that you're there and you're oftentimes sort of championing the latest research. Well, Dora, if we hadn't mentioned it, puts out some research papers regularly. Each year we have an annual report, and our 2025 annual report came out back in September. And this year's report is the state of AI-assisted software development. Now, I want to thank Octopus Deploy for being one of the sponsors of this year's research and the report. So thank you for your contributions there. That's super good. But this report, as it says on the title there, really digs into the state of AI-assisted software development. Steve, do you have any top takeaways or insights that you had from reading this report?
Yeah, I thought it was really interesting. There was relationships in there between things like platform engineering and AI. There was also a chapter that I really enjoyed on value stream management, which is super important when you're making improvements because if you haven't heard of theory of constraints or these kind of processes, if you kind of optimize the wrong part of your process, it either doesn't make a difference or it can make things worse. So that was super interesting. But there's also a very cool model in here that shows you what you need to have in place if you want to be successful using all of these cool new tools.
Absolutely. So let me recap some of those things and share some, again, just some more resources over here on the Dora.dev website. I'm going to go up to the guides section. And you mentioned value stream mapping and value stream management. We do have a whole guide on exactly how you and your team can put value stream mapping into practice. And it goes into a lot of detail, provides a lot of good insights into how to do this. And you may end up with something probably not quite as linear as this, but you'll end up with a good understanding of what does your software delivery process look like. To your point, Steve, we can find some bottlenecks. One of the things that we found in the 2025 report is we looked at how teams are incorporating AI is that AI is really sort of a mirror and an amplifier. And that amplification effect of AI, Steve, I think you probably gave me the best metaphor to talk about that, and it has to do with amplification. I hope you remember what it is.
I do, and I
Okay.
remember this because I obviously enjoy listening to bands, and I go and see a band that I enjoy, and they amplify them, and it's great because we can all hear them. But I also used to be in a band where I used to sing, and when I got amplified, things weren't quite as good. So it doesn't matter necessarily that this thing can make you a lot louder. You kind of have to do the right thing first before you then amplify it. So I should have learned to sing.
Yeah, there you go. There you go. Learn to sing. But this is one of the things that we've seen, with lots of teams using more AI to generate more code. Oftentimes, the time it takes you to generate code or the amount of code that you have is not the bottleneck in your system. So if you're generating maybe 2x, 5x, 10x the amount of code, and it has to go through that same approval bottleneck, you're probably not making things better. In fact, you might be making things worse. So we have to be careful about that. And this is one of the powers of value stream mapping. It helps us visualize our entire system and identify some of those constraints. Now, the other thing that you mentioned there, though, is a model. So I'm just going to pop over here to the AI tab because, it's 2025. Everyone's talking about AI. Actually, just this morning, talk about timely. This report is hot off the presses. We've just released today the AI capabilities model report. Now, the capabilities model is something that we introduced in the 2025 report, that state of AI assisted software development. And the reason we introduced it was because what we were seeing was nearly universal adoption of AI in our sample set, in the people that we were researching. But we were seeing huge variance in the types of performance that people were seeing. And that led us to this understanding that it's not AI that's driving all of the performance. In fact, it's not if you're using AI, because nearly everyone is, but there was maybe something to how you're using AI. And so we wanted to explore that, and our research to help us do just that. And it led to this AI capabilities model. And the way that this works is kind of similar to that core model that we looked at before. In fact, I would say that this is a nice complement to that core model that we looked at before. On the left-hand side of this model, we have AI adoption, which everyone is doing. You're probably doing it right now. How do we get more AI on this team? On the right-hand side of this model, though, we have some of those outcomes that you really care about, things like team performance, code quality, individual effectiveness, and so forth. And in the middle, we have these capabilities. And essentially what we're saying here is that when you have AI adoption coupled together, in this case, with strong version control practices, those strong version control practices will amplify the effect of that AI adoption on both team performance and individual effectiveness. So this model becomes now something that you can explore together. So if you wanted to, as an example, improve product performance for your team, you can come over here, just highlight the product performance outcome, and see that with AI adoption is going to have the strongest impact on product performance with access to internal data, with working in small batches. Hey, it's coming back, and a clear and communicated stance. Now, you can then dig into what each one of these means. Click on the capability. You can go ahead and learn more about that. And again, you'll find over here a capabilities article that talks about exactly what that capability is, how you can put it in practice, again, some of those pitfalls, why it deserves investment right now, maybe how to measure it, and so forth. So this is what we think is a really powerful way. And like I said, this model, this report just came out today. So honestly, Shipped is, well, it's the place where we're shipping this report. So thank you so much for having us, because I'm really excited to help teams understand how best to get the most out of AI.
Awesome stuff. Wow. I don't think you could have crammed more information in there. Thank you very much. And so just to remind folks, that AI capabilities report is now available, and that's dora.dev, is that right?
That's right, dora.dev.
All right. Well, there you go. Make it a bookmark, if not your homepage, as I like to say. Nathan, Steve, thank you very much for presenting. I really appreciate it.
Thanks very much.
Absolutely. That was a lot of fun. Thank you.
Awesome. All right, well, we'll say goodbye to those two, and we'll go ahead and go back to our schedule. We are in the last session of the day, Bridging the Gap, Empowering Dev Teams with Argo CD and Terraform at Scale, featuring Kelly and Graham. Graham is with HashiCorp, IBM company, and in this session, we're going to learn a lot about what those two technologies bring to the table in terms of empowering your dev teams, obviously, to ship at scale. So let's take a look at that now.
All right. Hi, everyone. Thank you for joining us here today. My name is Kelly. I'm a solutions engineer here at Octopus Deploy, joined by Graham, who is a resident architect at HashiCorp. Actually, fun fact, I used to work over at Hashi, so Graham and I go way back. We thought today would be a good opportunity to present to you on a topic that we thought was pretty relevant in the field that we operate and one that we come across very frequently. So the title of our session today is Bridging the Gap, Empowering Dev Teams with Argo CD and Terraform at Scale.
Hey, everybody. Kelly, it's great to see you again. Thank you so much for inviting me to present at Shipped. I'm very excited to talk about some firsthand experience that I have with unifying DevOps processes. I think we really have a better together story that makes a big difference. All right, so yeah, I have the privilege of kicking things off. So today we're going to be going through kind of a case study. All right, this case study is every bank, and every bank is literally every bank. I have a lot of experience working with large banks and the world's largest financial institutions. I see this pattern repeated over and over. It's a pitfall that many companies fall into. And I think we together, Octopus and HashiCorp, have a really good story to tell for how to get out of this mess, right? So banks grow by acquiring smaller banks and other financial institutions. Like, that's part of their core value proposition. However, this inevitably leads to challenges when a bank acquires a smaller bank that has incompatible cloud or DevOps processes, incompatible governance. It just creates a lot of sprawl and incompatibility. And this winds up creating hidden costs, is actually one of the main things that is a big deal for the companies that are doing the acquiring. They're acquiring these banks because they do something well, right? Because they make money. There's a hidden cost to integrating these companies after acquisition. And that hidden cost is buried in the challenge of unifying their DevOps processes. What's usually offered by these companies, and this is firsthand experience, is that they offer a manual process for doing this integration, right? So you're a company that got acquired, you're an app developer, you're very excited to be part of a large organization, and you want to participate in the governance structure and the new cloud offerings that every bank has to offer. It should be pretty straightforward, right? Well, you wind up filing a bunch of tickets, waiting around for a response. It's very dispiriting. And eventually, as somebody who's trying to do the right thing, you wind up saying, like, I don't have time for this. I'm wasting time. I'm wasting money. And so you wind up just kind of like resisting the integration, which is a problem, as we'll see here in a little bit, because it creates friction that keeps the different business units of every bank isolated from each other. DevOps chaos, the impact of a mixed estate. I think I painted a pretty good picture of like how every bank got into this mess. And what exactly does it mean to inherit a mixed estate, right? That sounds like a very innocuous term, but it gives a lot of people at every bank heartburn. Specifically, Terraform is used everywhere, but no two teams are using it the same way. They've got different modules, they've got different naming patterns, and more importantly, they have different security baselines. The main challenge for every bank is the latter one, right? The one thing that they can't tolerate is risk, so that they can't just leave things as they are. They can't just say, you guys are on your own. you did a pretty good job so far. Let's just go ahead and let you keep operating the way you are. They're forced by their auditors to make a change here, and that creates some issues. Teams wind up adopting Argo CD for continuous deployment, but they've got multiple installations of it. It's hard to wrangle all these processes. They've got many different environments and environment models, and it becomes a headache. So you're the CTO. What do you do, right? You need a plan that reduces risk, but increases the velocity of your developers. You and your leadership team must steer the bank towards a unified technology estate that encourages collaboration. All the while, you need to minimize the disruption on the teams, right? You don't want to kill the golden goose, because every bank just acquired a business unit that is generating revenue. However, there's a risk of continuing to do things the same way. So a unified delivery lifecycle involves Terraform, Octopus, and Argo CD. And the predictability that these tools bring together unifies delivery in a way that is scalable, secure, and cost-effective. How does Terraform Enterprise help in this regard? Terraform is sort of the foundation of your DevOps estate. It deploys the infrastructure, and it embodies governance and compliance with visibility baked in. There are ways to do this manually. They just take forever, right? The wrong way to do it, as I indicated before, is that you have a manual ticketing system. And this probably sounds familiar to every director ever, right? You've got a manual ticketing system. Somebody throws the request over the wall. Maybe somebody gets back to you in a timely fashion. They probably don't. Maybe your infrastructure looks the way it needs to, and maybe it's secure. It's very unpredictable and unknowable, and honestly, it's ungovernable, right? The right way to do it is to use Terraform Enterprise. This creates a unified platform where governance and controls and auditability and cost effectiveness are actually baked in. The term shift left applies here. You wind up granting developers the ability to self-serve their infrastructure in a way that's born compliant, so that they don't have to worry about participating in a long risk exception process or attesting to the justification of the cost of their cloud infrastructure. All of that stuff has been mandated and taken off their plate, and allows the app devs to actually do what they were purchased to do, which is make the application that is actually key to every bank's bottom line. You create adult supervision that helps everybody in the estate operate more effectively and without isolation. They can cooperate a lot more smoothly.
All right, awesome. Thank you for that great framing, kind of introducing us to who every bank is as a persona, what their main problems are. I hope some people in the audience, probably some of those points resonated with them. They're like, you know what, that use case sounds familiar. I'm dealing with that a lot myself. And also thank you for kind of presenting Terraform. I love to talk about Terraform. I did it at HashiCorp, and I still do it today, every single day at Octopus, because so many of our customers are using Terraform. And what Graham just kind of touched on there and set us up nicely is kind of the day zero problem, right? And that is the infrastructure provisioning. So what Terraform does a great job of doing is allowing self-service, allowing those guardrails, a compliant workflow to create and spin up the infrastructure that you need to deploy applications, right? Because at the end of the day, where you're really getting monetary value from your organization is you want to create applications that are continuously churning out new features. And you can't do that if you don't have the infrastructure in place to deploy those applications. One way that a lot of that feature development gets stalled is when you don't have a process, you don't have a tool in place like Terraform that enables you to do it. So with that being said, let's dive into kind of the day one, right? Because when we talk about what it takes to get an application out to production, you often hear day 0, day 1, day 2. We chatted about day 0 with Terraform. Let's talk about Argo CD. So as a CTO or any other technical decision maker or technical person on this call, you might very well keep hearing Argo CD. I certainly I think it's been around for years and it's been loved for years, but I really feel like it's skyrocketed in its adoption, its usage just in the past couple. Octopus, we've gone to a number of different conferences recently. A lot of folks come up to our booth and they point at the Argo logo and they're like, tell us a little bit more about your integration. Like, tell us how do you work with Argo? We love Argo. And a great thing is we actually have some of the top maintainers, contributors to the open source Argo project at Octopus. So the reason Argo is so great is it's an open source tool, and what it excels at is Kubernetes deployments. Developers like it because it honestly abstracts away a lot of the technical, intricate details of Kubernetes, and it allows you to do exactly what you want, is just get your applications out to K8 clusters. And it's built on the premise of GitOps. And GitOps is the methodology that everything should be sent through Git. Git should be the central source of truth. And anything outside of that is out of compliance. It's not the workflow that we want for our developers. So what Argo CD will do is not only allow all changes to Git to be implemented in Kubernetes, but in the event that a nefarious user or actor goes in and makes a change to the application on the cluster itself outside of Git, Argo will also recognize that and can automatically remediate the application. Or if any things happen or occur with the Kubernetes resources themselves, like the pods, it can have an automatic remediation and spin those resources back up. So that's the value prop of Argo. That's why folks love it. The challenges, though, with Argo is that it wasn't designed to really mimic an enterprise-grade continuous delivery solution. It doesn't have the concept of environments, dev, staging, test, production. It doesn't have that. So a lot of the times developers will have these ad hoc solutions that they create. They'll append -dev, -staging, -prod US West too, et cetera, onto individual applications. And you have no way of logically grouping some together, right? Because hypothetically, all of those, the dev, the staging, the prod should be the same base application code with just some slight nuances depending on the environment. But now when you're just basically appending or changing the name of it, you're creating kind of isolated applications. So it doesn't have that environment, it doesn't have that product grouping that you're looking for. And oftentimes your developers end up having to use, glitter glue and duct tape to kind of stitch together a more well-rounded CD solution. So like I just kind of stated here, and Graham mentioned earlier, managing one application, managing just a handful, or maybe just having a couple of developers using Argo CD, yeah, it's relatively straightforward. It's relatively doable. The problem really comes in is when you're trying to add complexity. So imagine now, instead of just one Argo CD instance with 10 applications, you now have 5 to 10 instances with hundreds to thousands of applications, and similarly hundreds to thousands of Kubernetes clusters. So now you could potentially be dedicating a DevOps engineer or an individual just to the maintenance of Argo CD. So there's really no single pane of glass. You're logging in and out of these instances, trying to track down where these, each of these individual applications reside. So no sense of RBAC. Again, no environmental progression.
That's totally every bank. Every bank has thousands of applications. Every bank has thousands of Argo CD installations. Every bank has tens of thousands of developers. So every bank is struggling with exactly that kind of scalability. And, Argo CD was the perfect solution for the business units before they got acquired. And it's become a bit of a quagmire post-acquisition.
Yeah, absolutely. So let's kind of chat about what's the solution to this problem that I just posed, right? And in my mind's eye, it's really Octopus. I think Octopus fits in well with this problem that we're facing with scaling Argo CD. So If there's any CTOs listening or folks who, you're aware that Octopus is in your tool stack, but you're not too familiar with the intricacies of it. At the end of the day, it's really developed to be an enterprise grade CD solution. So a little bit of background, a lot of folks, they might adopt an all-in-one solution, or they might do a lot of custom scripting, which again, similar issue to the Argo, the primary Argo issue is that works well at a small scale. But imagine trying to have hundreds of custom scripts just to get your applications out to staging and QA and production. So what Octopus provides is it provides environments clearly defined: development, staging, test, production. It allows you to logically group applications together and define a promotion lifecycle for that. So in your Octopus deployment process, if your developers want to reference the unit tests that they need to run, the smoke tests that they need to run, if they want to attach an SBOM with their deployment artifact, those are all capabilities that you can have all within the platform itself. So how does that relate to Argo? What I pointed out and what Graham was touching on there, again, the environment progression, something that's lacking in Argo, you could get with Octopus, and it will allow you to have that single pane of glass, onboard all of those hundreds, tens, hundreds of Argo CD instances that you currently have, and have it all on the Octopus platform. And just integrate with the existing RBAC controls or ITSM integrations that you're currently leveraging.
That, by the way, every bank has that problem, right? So GitOps sounds good when at small scale, and it does exactly what it is promised. Argo CD delivers on exactly what is needed. But as any dev can tell you, like trying to integrate your GitHub workflows with your Active Directory, with your groups, with your approval workflows that are baked into some other third-party tool, it's a nightmare. Every bank has this issue, and every bank needs Octopus as the glue between their infrastructure and their deployments, right?
Yeah, absolutely. So like I just kind of touched on this, but it's onboarding, like I said, your multiple Argo CD instances in all of the Kubernetes clusters, all of those applications onto the platform. So now rather than having, kind of a stitched together naming convention of -dev, -prod, whatnot on Argo CD, you can logically map that application to a project in Octopus, and then still define the subsequent, dev, test, staging, production environments. And you'll also be able to retrieve the live object status, the last deployment, the health of both your application and your Kubernetes resources directly on the Octopus platform. So kind of tying this all together. And Graham, you brought up a good point about GitOps. The reason that folks love Argo and they don't want to go away from it is because GitOps is a really reputable, style of deployment, and you can continue to support that with Octopus. You can integrate that into the platform. You can still, force all changes to your applications to be going through Git, for Git to be the central source of truth. But I think, and maybe this will kind of, lead into our discussion, Graham. But the interesting point is that you have this developer team, maybe you have multiple developer teams at this company that was acquired, and they're holding tightly onto Argo. They're like, we don't want to let go of Argo. Like we love it. We work well with it. And you get to tell them, you don't have to get rid of it. You don't have to. You can continue to use that. But listen, we at the acquiring bank, at every bank, we have some dev teams. They're already using Octopus, and they're actually using Octopus for some traditional style deployments, some IaaS servers. Maybe they're doing some mainframe with IBM, whatever the case might be. Like Octopus can field like multiple deployment styles, so you don't have to restrict yourself to one or the other. You can just bring them under the same umbrella. Yeah,
and so what you were just describing makes me think that, right, what I want from a GitOps, as a developer at every bank want from a GitOps deployment is I want declarative deployments, right? I want to declare this is the way it looks. Now just go make it look that way, right? And don't add anything extra. If something bad happens, I want you to rebalance my deployment, that has real power. And if there's a very short line between my laptop and production, that works great. I can just write up some code, containerize it, declare a deployment, and off it goes. Every bank has a much longer process, right? Like, because every bank processes trillions of dollars of transactions in a month, right? Every bank holds tens of trillions of dollars of assets under management, right? Like, the scale doesn't allow you to just kind of wing it when it comes to approval processes, right? So I know I can deploy provisioned, secure, born compliant infrastructure that meets my needs, and I can self-serve it. And I know for sure that I can declare a deployment that looks exactly, and I can trust Argo CD to make it look that way. How do I participate in an automated workflow that actually cooperates and embodies every bank's deployment processes? And that's totally Octopus, right?
Yeah. Well, I think that's a great point. And I think this is definitely a thread that we should pull on, right? Because if I'm a CTO listening to this conversation, I'm kind of thinking, all right, that's all well and good. I have these 3 tools. I'm keeping them in my tool stack, but like, how am I controlling who gets to operate Terraform, who gets to do these things with Argo and these things with Octopus? Well, that's where kind of the intricacies of all of these platforms couple together, right? So with Terraform, you mentioned it at the beginning, you get to define your Sentinel policies that create guardrails around the infrastructure that's provisioned for applications. Well, then in Octopus, you get to also define what developers are allowed to go to development, what developers are allowed to be an approver, be a manual approver during an intervention step. Who can edit a deployment process versus who can't. And if you wanted to go so far as to create a template, and you as the engineering lead, the app team lead, you get to define, this is what our deployment process is. It consists of these steps. This is where you're deploying your Terraform. This is where you're doing some database changes. This is where you're actually deploying your site itself. This is where, X, Y, Z. You can define that template, and then you push it out. This is all on the Octopus platform. You're pushing it out to your developers, and they can just select, I want to choose that template. I'm going to consume that. And then if their manager ever wants to make a change to it, they change the template, they version it, they publish it, and their developer, who's the downstream consumer of it, now has the new compliant template. And they don't even have to think about how to deploy, or they don't have to worry about if they have the right permissions. It's already been decided for them.
Yeah. So what pops into my mind when I hear this in reducing risk, this is exactly what I was just about to talk about. Every bank has a permit to operate process, and a permit to operate process is long, it's tedious, it is not self-serve, but it exists for a very good reason. And that good reason is that as a CTO, and as a CTO, my peer is the CISO, right? And the CISO is like, I'm not going to let you guys just like dump anything onto my public cloud. We're going to have to go step by step and make sure that everything is compliant, everything is well architected, and that your software development lifecycle adheres to our best practices. Well, guess what? Terraform Enterprise lets you actually just take the controls that cyber has handed down as requirements for compliance in your permit to operate process. You just bake them in as Sentinel policies, throw them into TFE. It's impossible to deploy something that is non-compliant. So you've just scratched that whole step off your list. And so TFE helps solve the baseline infrastructure compliance problem. Octopus does the same. You just described a permit to operate process that every bank has. That's how they comply with the regulations, such that they're auditable, it's trackable, and it uses least privilege RBAC controls. This is how you eliminate or dramatically reduce your permit to operate process. So every bank CTO really cares about this solution, not for the details, but for what it actually eliminates process-wise. You keep your compliance, you keep your governance, you keep your auditability, and you dramatically increase developer velocity. So that's really what this is about.
Absolutely. Yeah, I think I couldn't have said it better, Graham. I think you summarized it really well. It's there's a lot of implications, like you said, as you kind of introed when we first began this discussion. I think, Graham, when you and I were thinking the other day and kind of ideating on this talk and what we wanted to talk about, you used a fun kind of visual, which I like. I wanted to bring it in, but you were like, yeah, when this acquisition goes through, everyone's, popping the confetti and shaking hands, and we're excited. Like, this is great. Let's go. Let's get off to the races. But there's an unfortunate reality behind that. It's like we've done that. This great event has taken place, but now you have to look like, what is actually our path to profitability and actually integrating this entire new operations team, developers team, the tool set into what we currently do. Where do we decide like how this is all going to flow together? And a lot of times folks, it's years down the line before they figure this out. And years down the line means millions, hundreds of millions of dollars that are lost in kind of, honestly, a lot of like shadow IT operations, because it's easy to neglect or not realize the monetary value that's attributed to having to maintain these systems manually. So you can automate what you were just mentioning there, Graham, like the compliance, the auditing, and also the process with which your developers can push to production. Like you are really seeing your time to value for that acquisition.
And that's what it's all about. It's about time to value, right? A lot of really smart people did due diligence to research this acquisition and make sure it pencils out. There's a clock ticking once the acquisition happens for that math to pencil out. And if you blow past that limit, you're eating into your margins, and somebody's going to be wrong and probably get fired, right? So you need a path to ease of use, ease of integration. Terraform has the acquisition. Terraform has the infrastructure piece of the acquisition completely nailed down, but Terraform is not how you deploy and manage your applications. And you need a flexible framework that can kind of ranch all these different tens, hundreds, and thousands of applications. Because guess what? If you fall behind on this one acquisition, bringing them into the fold, there's due diligence happening right now on your next acquisition, and every bank is about to pour some more gas on that fire, right? So I can't stress enough. This stack, I would almost like orient it as a line. This platform that is broad shoulders to stand on. If you're a CTO, if you're a CISO at every bank, like, I know you know the pain that I'm talking about, and I can tell you from firsthand experience, this is how you should solve it.
Yeah, absolutely. I think, Graham and I, we had multiple kind of working sessions to chat through this, and oftentimes we would talk for like an hour just with each other, at each other, like bouncing ideas, because every day Graham and I have, a number of customer conversations, and it's with financial institutions and folks from all different industries, all different verticals, and they're all facing this problem too. I think that's important to note. It's like, this absolutely applies to banks, but it also applies to, medical care practices, local governments, all different, types of folks who have an application. They have multiple application or developer teams. They're going through an acquisition. They have all of these tools that they're presented with, and trying to figure out what needs to be kept or not. And I think, as you alluded to, Graham, as you surmised, like, this stack here is an extremely powerful one.
Yeah, no, I mean, I've seen it. I've seen it in action. It really does work. It solves exactly the problem that we're describing. You make a really good point. Number one, every bank is not any bank. It's not any one bank. It's literally every bank.
Yeah.
But two, that's just, we picked that example. We picked every bank because it is the easiest way to visualize how rapidly acquisitions grow. It's like kudzu. They just proliferate, and it's the easiest way to get into trouble. But this happens all the time with new applications being developed by teams that are allowed to operate in a silo. And one team prefers Azure, and another team prefers GCP, and another team can only operate on-prem for various reasons. And pretty soon you wind up trying to wrangle DevOps practices that are entirely disparate from each other. And as the CTO and CISO, you guys just can't tolerate that, right? There's too much risk. At some point, something bad is going to happen, and heads are going to roll, right? So better to get out ahead of it, make sure that you understand how to deliver infrastructure that's born compliant, environment-based approval workflows with clear segregation between pre-production, production, approval gates, and GitOps-based deployments that are the gold standard of how you manage containerized workflows. So, I mean, you'd be crazy not to do this, right? The alternative literally is like Bash scripts, PowerShell scripts, some Lambda functions. I mean, it's just an absolute, it's the Wild West.
Mm-hmm. Yeah. And to be clear too, like I know Graham and I have spoken a lot to that CTO, like more that technical decision maker trying to understand their tech landscape. But developers like really are benefit from this as well, right? We're by no means trying to still lock them into a box and say you can only deploy to this cloud, or you can only deploy to Kubernetes, or you can only deploy here. Like, no, that's certainly not the case. It's more of like, how do we create the structure for them to then go do what they do best, which is deploy to multi-cloud environments. Octopus supports Azure, GCP, as you mentioned, or deploy to Kubernetes on those given cloud providers, or deploy to IaaS, deploy to mainframe, whatever the case might be. It doesn't matter if it's legacy style deployments or more Kubernetes style deployments. It can all be done through Octopus. And the products themselves, the applications can at the heart be different than one another. But you still have this overarching structure for how you define how they operate.
Totally, right? Yeah. Argo CD is beloved by developers because it makes deploying easy, right? These are the people that are adding the value. They're writing the application that makes the enterprise tick. And I used the phrase before, but like, you don't want to kill the golden goose, right? This is why you're in business. And in a real sense, all of this overhead is a distraction. It's pure negative from the developer standpoint, right? So these tools are designed to give developers what they want as well. Stay out of their way, increase their velocity, increase self-service, while at the same time providing the guardrails and the compliance and the auditing that is required for sort of like moving into a much larger pool. I think that's super important to keep in mind, right? And that's the bind, right? What always happens at every bank is an app team gets acquired. They were moving with high velocity. That's what made them attractive for acquisition in the first place. Every bank layers on this thick coat of procedure and policy and permit to operate, and everyone hates it because the developers hate it because it gets in the way of them doing what they were supposed to be doing, and every bank's C-suite hates it because it puts everybody behind and it eats into the margins of your acquisition. So I have enough experience to know that this is the type of automation that is critical for every bank to actually realize the time to value and the value of the acquisitions that they make.
Yeah, absolutely. I don't know how that went by in the blink of the eye. I just think that's the nature of when you and I get on a call, Graham.
Totally.
Just I don't know. I feel like we could chat for hours, but it's an important use case. Like we said, it's one that we personally encounter every single day. I think you and I love talking about this stuff. So if anyone wants to continue chatting about it, tell us about your use case. You know where to find us or find Octopus, find HashiCorp. But, Graham, thank you so much. I love collaborating. Hopefully we do something like this again in the future. This has been awesome.
Yeah, it's my pleasure. Thank you.
Awesome stuff. Thank you very much, Kelly. Thank you very much, Graham. That was a great presentation. I'm a huge fan of Terraform. I've been working with Terraform for many years, and I think it's a wonderful tool. Combined with Argo CD and Octopus, that's like a peanut butter and chocolate combination if I ever heard one. Anyways, we are at the end of day one. Congratulations, you made it to the end. We saw a lot of stuff today. We saw, obviously, our keynote presentation by Paul. We saw a session by Colin talking about all the stuff that we built and stuff that we are building. We had our release party as well. We had sessions by Bob, by Costas, by Jim. We had the research panel featuring Steve, Matt, and Charlotte. Kit did a couple of sessions, one on Kubernetes deployments, practical guide with Liam, and he did another one on GitOps with Robert. And you saw a session there by Michael and Bestie on Save a Canary, Flick a Toggle, feature toggles in Octopus. We then just recently had Steve and Nathan do a session on Dora, and then just wrapping up now, Kelly and Graham featuring Terraform and Argo CD. So congratulations, that is the end of day one. Day two, just as intense, but this will feature a lot more customers and partners. So you're going to hear a lot of stories from customers and partners who do work with Octopus, who are building things out there. We have a lot of great speakers there, so I would actively encourage you to come and check it out. You'll find this all up on the Shipped website. So this is at /shipped. And you can see we're streaming there now, and I'm sure I'll probably appear there in just a second. But yeah, so if you go to octopus.com/shipped, this is your sort of one-stop shop for all things shipped. Just go here. This is where we're going to host the live stream. It's probably easier than going to some other location. We'll just embed the YouTube player, but that's something that you can definitely use. The other location you want to make sure you keep in mind is our YouTube channel. Make sure you, as the kids say, like and subscribe. You can see here that some of the videos have already been starting to be published. So if you want to go back and see the full fidelity recording of the sessions that were done, go and check out our YouTube channel. And while you're there, make sure you subscribe and maybe check out a show or video or two. We publish all the time. Anyways, with that, I am very happy to say that is the end of day one. I really hope that you had a good time, and we will be back here, same bat time, same bat channel on octopus.com/shipped for day two. And as we always say, from behalf of us to all of you, happy deployments, everyone. We will see you tomorrow.